Ladies and gentlemen, may I have your attention please? We are about to begin our agenda today, so please find a perfect seat, turn on your camera, and make yourself comfortable. Good morning on Jakarta time. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh.
Best wish for all of us. Shalom, Om Swastiastu, Namo Buddhaya. Welcome to the 14th International Conference on Advanced Computer Science and Information System, the 7th International Workshop on Big Data and Information Security, Seminar 22. My name is Hafiz Shafi'i. I will be your host today, live at the Faculty of Computer Science, Universitas Indonesia. In this occasion, we are pleased to welcome Director of the Professor Ari S.E. Defense Vice Admiral of Indonesian Navy, Professor Dr. Insinyur Amarullah Octavian, MSc DESD ASEAN Engineer. The Dean of the Faculty of Computer Science, Universitas Indonesia, Dr. Insinyur Petrus Mursanto, MSc. The Dean of the Faculty of Defense Technology Faculty of the Republic of Indonesia Defense University, Rear Admiral of Indonesian Navy, Dr. Kasih Prihantoro, SE MM MTRhan. Vice Dean of Academic, Research and Student Affairs, Faculty of Computer Science, Universitas Indonesia, Dr. Ari Sapta Wijaya. Vice Dean of Defense Technology Faculty of the Republic of Indonesia Defense University, Air Force Marshal of Indonesian Air Force, Dr. Insinyur Rudi Agus Gemilang Gultom, MSc. The Chair of IEEE Indonesia Sections, Dr. Ing Wahyudi Hasbi. General Chairs and Program Chairs of ICACSIS and IWBIS 2022. And special welcome to all plenary and keynote speakers that join us today. Professor Rajkumar Buyya from the University of Melbourne, Australia. Associate Professor Dr. Mahardhika Pratama from University of South Australia. Major General of Indonesian Army, Dr. Jonni Mahroza from the Republic of Indonesia Defense University. Professor Maria Valdes Hernandez from University of Edinburgh, United Kingdom. Associate Professor Dr. Wahyu Caesarendra from University of Brunei Darussalam. Dr. Adhiguna Mahendra from Nodeflux and Indonesia AI Society. Air Force Marshal of Indonesian Air Force, Dr. Rudi Agus Gemilang Gultom from the Republic of Indonesia Defense University. And also, very warm welcome to all distinguished guests, presenters, and all participants. Before we proceed further to this morning's session, we would like to invite you to rise for the national anthem of the Republic of Indonesia, Indonesia Raya. To all participants, please have attention. Participants, please be seated. We are very grateful to Universitas Indonesia and the Republic of Indonesia Defense University for the tremendous support to ICACSIS and IWBIS 2022. This event is also held in conjunction with the Indonesia International Defense Science Seminar 2022. The International Conference on the Advanced Computer Science and Information Systems, or ICACSIS, and the International Workshop Data and Information Security, or IWBIS, brings together academia, researchers, entrepreneurs, and policymakers in an international forum designed to examine key innovation and research in area of computer science, information system, big data, and information security. The 14 ICACSIS and 7 IWBs have managed to screen dozens of papers from more than 10 countries to be presented in parallel sessions. Although this event is held virtually, we hope that this enriching experience for all of participants. Ladies and gentlemen, without further ado, let us welcome Director of Universitas Indonesia, Professor Ari Kunchoro, SE, MA, Ph.D. Prof. Ari Kunchoro, the time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Om Swastiastu, Namo Buddhaya. Peaceful greeting to all of us. On behalf of the Universitas Indonesia, I would like to extend our warmest welcome to all participants of the 14th International Conference on Advanced Computer Science 2022 and the 7th International Workshop on Big Data and Information Security 2022. It is an honor to welcome you all to these 3 co-located virtual events in the middle of this pandemic situation. Universitas Indonesia has a strong focus on research and envisions herself to become one of the top referral higher education institutions in Asia. The university promotes multidisciplinary research involving collaboration across different areas of research. The Faculty of Computer Science is an important part of UI, who pioneer education, research, and community services in the broad areas of computer science and information systems. With the world entering the information age and the 4.0 industrial revolution, expertise gained through advanced research in computer science and information technology is critical. Through the faculty, UI hopes to significantly contribute to the prosperity of the nation by impactful work in the faculty core subject areas. Organizing a conference is a means of expanding and strengthening the network of collaboration existing with a new partner from academic community and industry. Exchange of ideas through conference activities can spur the development of new frontier of research. Moreover, such events offer opportunities for researchers, students alike to obtain valuable feedback from fellow researchers and members of scientific community on the work they are doing and presenting at the conference. Along the above line of thinking, UI applaud the effort of the Faculty of Computer Science to organize ICACSIS and IWBIS now in their 14th and 7th year, respectively. This demonstrates the commitment of the faculty to advancing research through strong research collaboration internationally in the midst of challenging pandemic situation worldwide. We are honored that this year ICACSIS and IWBIS are able to host several distinguished speakers from the world-leading researchers and luminaries. The list includes Professor Rajkumar Buyya, Director, CEO of Cloud Computing and Distributed System Lab, the University of Melbourne, Professor Jeremy Blackburn, Assistant Professor of Department of Computer Science, Binghamton University, New York, Dr. Wahyu Caesarendra, Assistant Professor of Faculty Integrated Technology, University Brunei, Darussalam, Brunei, Dr. Mahardhika Pratama, Associate Professor of Academic Unit of STEM, University of South Australia, Adelaide, Australia, and Dr. Adhiguna Mahendra, Chief of the AI and Product, Vice Director of Industrial Collaboration, Nodeflux Indonesia AI Society. In addition to them, ICACSIS and IWBIS also host a spread list of speakers that surely can provide valuable insight and inspiration to all participants of both conferences. I would like to express my sincere gratitude to the distinguished invited speaker for their presence and contribution to the conference. I also thank all the program committee members for their efforts in ensuring a rigorous review process to select high quality papers. I would like also to mention the support of the IEEE Indonesian section, the Republic of Indonesia Defense University, Indonesia International Defense Science Seminar, and for their generous support as technical co-sponsor and host that enable this event to go ahead in this challenging time. This activity is also special considering that apart from international conferences, there are follow-up activities in the form of workshop and tutorial on artificial intelligence. Finally, I sincerely hope that all participants will benefit from the technical content of this event. Furthermore, despite the virtual setting, I sincerely hope through both conferences, some fruitful and hopefully long-lasting collaboration can be established and all participants can return home from all events enriched and inspired to do more impactful work for society. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Prof. Ari, for the welcoming speech. Ladies and gentlemen, we continue with the speech from the Rector of the Republic of Indonesia Defense University, Vice Admiral of Indonesian Navy, Professor Dr. Insinyur Amarullah Octavian, MSc, DESD, ASEAN Engineer. Vice Admiral Professor Amarullah Octavian, the time is yours.
Thank you very much, moderator. Good morning. The Honorable Rector of the University of Indonesia, Professor Ari all three. Currently, the world has got familiar with open access intelligence, namely the extraction of information from open data that flow in cyberspace. Many matters which previously required special intelligence operation to inquire and analyze a strategic or tactical condition can now be done by using open access intelligence. Nevertheless, without the support of an artificial intelligence system, OIE activities cannot produce optimal results. Likewise, the phenomenon of security hacking, whether those carried out by radical militant groups such as Al-Qaeda, Hamas, GI, ISIS, or those supported by countries to the several states or vice versa, require the role of intelligent machine to automate this protection and attack. Furthermore, this smart machine can be used for various strategic and tactical needs by changing the parameter setting as needed. There have been 3 significant changes in the Industrial Revolution, and we are currently experiencing the 4th Industrial Revolution. Each of these significant changes is always followed by major change in the economic, political, even military and cultural field. One of the clear examples is the loss of million jobs or all jobs and the emergence of million brand new jobs caused by the Industrial Revolution 4.0. Some activities in the production process, which initially were so tricky, long, and expensive, now have become easy, fast, and cheap. Economics discuss various human efforts to deal with scarcity. The Industrial Revolution reduced and eliminated some of these scarcities so that the time, energy, and money initially used to overcome these scarcities were suddenly free and could be used for other things to address other scarcity. The loss of reduction of a scarcity automatically changed many aspects of social life. Ladies and gentlemen, according to Snyder et al. 2012, big data cover data collection with a size beyond the capabilities of software tools that are commonly used to capture, create, manage, and process data within a tolerable end time. Easiness in understanding is the ability to extract meaning based on extensive data collection from various sources. Meanwhile, artificial intelligence, according to Poole et al. 1998, is any device that is capable of understanding its environment and taking action that maximize its chance of successfully achieving its goal. Understanding the substance is to make a machine able to learn automatically, which term as machine learning. The combination of the two result in a learning organization, which improve organization ability to gain in-depth and dynamic understanding about its environment, from which the ability is not just to anticipate, but also to make changes through its structural intervention. Thus, the term big data intelligence emerged and can be applied to various fields from business to defense and security. Artificial intelligence is part of the Industrial Revolution 4.0. It is a field of computer science that can do things like human do and think the way human want. The development of artificial intelligence is significant, both now and the future. The benefit of intelligence is to develop method and system to solve a problem that human can also solve. In economic and finance, AI help in various matters, such as financial investment, financial record, buying and selling stock, fraud and criminalization in bank and others. In education, robot tutor have been introduced in the classroom to teach children everything from biology to computer science, although this has not been widely practiced. Meanwhile, machine learning of AI is used to assess what its students need to improve in the learning process. In industrial sector, robots are often employed to replace humans, especially in repetitive work, such as automatic machines in factories that help the production process of a product. In the field of defense and security, AI has been utilized for assisting to predict, detect, and prevent various tendencies that threaten the defense and security of the society and state. Distinguished participants, the government realized that the importance of protecting personal data has begun to strengthen along with the increasing number of cellular phone and internet users. It is in line with the 4th paragraph of the preamble to the 1945 Constitution of the Republic of Indonesia. The government of the Republic of Indonesia has a constitutional obligation to protect that entire Indonesian nation and homeland of Indonesia, and to promote public welfare, educate the nation life, and participate in the implementing of a world order based on freedom, perpetual peace, and social justice. Personal data protection is currently regulated in separate law. Therefore, it is still not integrated. For instance, Law number 36 of 2009 on health regulate the confidentiality of the patient condition, while law number 10 of 1998 on banking regulate personal data regarding depositors and saving. This is insufficient because those laws do not protect personal data integrally from the spectrum of activities that require personal data provision for various purposes, both online and offline. If this is not anticipated and controlled, then the right to personal data will be very vulnerable to exploitation, both for the motive financial gain and the motive of national security, and ultimately will harm Indonesian citizens who are the subject of state protection. For this reason, the government of Indonesia has submitted a bill on personal data protection through the Ministry of Communication and Information. Then the Parliament has recently passed the law on personal data protection on September 21st, 2022. Against this background, I hope this conference will become a mutual platform for all of us across the entire nation to provide the best protection for our beloved citizens. At last, I hope this conference will run successfully and bear a fruitful result. Thank you very much. Wish you all the best, and salam bela negara.
Salam bela negara. Thank you, Vice Admiral Professor Amarullah Octavian, for the opening remarks. The next agenda is the speech from the Dean of Faculty of Computer Science Universitas Indonesia, Dr. Insinyur Petrus Mursanto, MSc. Dr. Mursanto, the time is yours.
Assalamualaikum. Assalamualaikum warahmatullahi wabarakatuh. Shalom, Om Swastiastu, Namo Buddhaya, Salam Kebajikan. A very good morning, the Honorable Rector of Universitas Indonesia, the Honorable Rector of Republic of Indonesia Defense University, the Honorable Dean of Defense Technology Faculty, the Defense University, our distinguished speakers, all our respected presenters, ladies and gentlemen, participants and guests. It is a great pleasure for me to welcome you to the 14th International Conference on Advanced Computer Science and Information Systems and the 7th International Workshop on Big Data and Information Security. And this year, these two conferences are held in conjunction with the International Defense Science Seminar. We have been organizing these two conferences regularly as part of a series of events in our Dies Natalis Faculty of Computer Science, Universitas Indonesia, in which celebrates the 36th this year. We are glad to know that the participants of the conferences are increasing from time to time, showing the great interest and enthusiasm among the academics, researchers, practitioners, and also industrial community. As the name implies, ICACSIS covers a broad field related to information and communication technology. ICT provides enormous benefits for individuals, organizations, and society at large. Meanwhile, the IWBIS discusses more specific topics. Questions around data privacy, information security, impact of abuse, and prevention effort can be resolved by combining technical expertise with social and environmental awareness. Therefore, all stakeholders in the ICT field must be prepared for responsibility for all the changes that innovation can bring. This all reflects that the ICT has an important role in many ways in our life, in which we have increasing demands to be able to provide solutions for various needs. We do hope that this online conference has the same intensity to interact one another through lots of discussion, sharing thoughts on the research topics presentations, as well as to build networking amongst the researchers and practitioners, which create positive collaboration for professional participants and also for the institution involved. We would like to express our heartfelt gratitude to all of you, everyone present here, and particularly for speakers, papers, presenters, and the committee who sincerely dedicated to this event to make it a success. Special thanks are due to our organizing partner, IEEE Indonesian section, who technically support these conferences with their expertise and skills. Especially, I would like to thank to the following plenary speakers: Professor Rajkumar Buyya, the Director of Cloud Computing and Distributed Systems Lab, the University of Melbourne, Australia. Professor Jeremy Blackburn from Binghamton University, New York, Professor Maria Valdes Hernandez from Center for Clinical Brain Sciences, the University of Edinburgh, UK. My pleasure to welcome the following keynote speakers: Dr. Wahyu Caesarendra from Universiti Brunei Darussalam, Brunei; Dr. Mahardhika Pratama from University of South Australia, Adelaide; Major General Jonni Mahroza, Ph.D., the Vice Rector for Academic and Student Affairs, the Republic of Indonesia Defense University. My sincere thanks to you all. In addition to those I have mentioned, I also want to call on our institution partners, the Republic of Indonesia Defense University, as co-host of these ICACSIS and IWBIS. These conferences would have been impossible without the support of each and everyone present here. Thank you all for making this a truly great international conference. We ensure the conferences will be profitable and fruitful for all of you. Enjoy the conference. Wassalamualaikum warahmatullahi wabarakatuh. Om Santi 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 Om. Namo Buddhaya.
Thank you, Dr. Mursanto, for the opening remarks. Ladies and gentlemen, we continue with the speech from the Chair of IEEE Indonesia Sections, Dr. Ing Wahyudi Hasbi. Dr. Wahyudi Hasbi, the time is yours.
Excellencies Rector of Universitas Indonesia, Professor Dr. Ari Kunchoro, AC, ME, Ph.D. Excellencies Rector of Republik Indonesia Defense University, Vice Admiral Professor Dr. Insinyur Amarullah Octavian, MSc, Asian Engineer. Excellencies the Dean of the Faculty of Computer Science Universitas Indonesia, Dr. Insinyur Petrus Mursanto, MSc. Excellencies the Dean of Defense Technology Faculty of the Republic Indonesian Defense University. Excellencies the Dean of the Defense Strategy Faculty of the Republic Indonesian Defense University. Excellencies the General Chair of the Conference of ICACSIS and IWBIS. Excellencies my colleague Professor Dr. Wisnu, all distinguished keynote speakers, all participants, ladies and gentlemen. It's such an honor and a pleasure for me to be able to greet you all and give a few words to represent the IEEE Indonesia section at the opening of this conference. On behalf of the IEEE Indonesia section, I would like to extend a very warm welcome to all of the keynote speakers, presenters, participants attending the 2022 International Conference on Advanced Computer Science and Information, or ICACSIS, and the 7th International Workshop on Big Data and Information Security, IWBIS, in conjunction with International Indonesian Defense Seminar, and hosted by and organized together by Faculty of Computer Science Universitas Indonesia and Republik Indonesia Defense University, and also technically sponsored by IEEE Indonesia sections. These two events provide an international forum that brings together those who are actively involved in the field of computer science and information systems, and also as an international forum designed to examine key critical areas. In this occasion, I would like to congratulate all the committees of this board conference for organizing this conference. This distinguished guests, colleague, researcher, professional, ladies and gentlemen. In our daily life, numerous types of data are generated. This information is then kept and handled. Some businesses may use this information for personalized marketing and to deliver services according to individual interests and preference. As we are progressing into the future, however, we are entering the era of the data-driven civilization, in which the actual world and data are intricately interconnected. In other hands, the data security and privacy have always been as the level of data protection can't keep up with the data growth rates. We have also seen rising cases of data breaches in Indonesia that assign to urgently enact the data protection. We understand that recently the Personal Data Protection Bill has been issued by our parliament. The statistics also demonstrate that the scale of the problems based on the Statista, as 2022, the global average cost data breach amounted 4.35 million US dollars, an increase from 4.24 million US dollar in the previous years. In such so, I believe that the theme of the conference is very important in highlighting the innovation to accelerate the shift to digital and fundamentally shake up the living landscape. Distinguished guests, keynote speakers, ladies and gentlemen, IEEE Indonesia as a regional organizational unit was founded in 1988, and over the past 34 years, we have contributed significantly to various activities that encourage science and technology for humanity in Indonesia. Together with all volunteers, members, and stakeholders, we have produced and supporting more than 70 high-quality conferences every year, including this board conference. Compared with the previous years, for example, in 2021 itself, the conference supported by IEEE Indonesia increased by 50%. And as we all know, all the high-quality conference of IEEE will be submitted to IEEE Explore Digital Library, indexed by Scopus, Web of Science, and any other major databases. And with more than 6 million publications and more than 15 million downloads every month. In other activities, IEEE also developed industrial standards such as IEEE 802 as a standard Wi-Fi, for example, that we use in our daily life. IEEE Indonesia also holds more than 40 professional, technical, and non-technical and administrative activities for all our members. And currently we have 27 technical society chapters, including 34 university student branches. And all these chapters become a forum for our members to have various international technical collaboration and social activities and provide Indonesian student member an experience. Next month, there will be an IEEE Extreme Challenge, a 24 programming challenge that's very challenging for students all around the world and can bring the global competitiveness for our students. In 2021, IEEE Indonesia already established a cooperation agreement with the Directorate General of Higher Education, Research and Technology, in which IEEE Indonesia support the Indonesian Ministry of Education, Culture, Research and Technology program, including supporting the Campus Merdeka, Merdeka Belajar. And this historical collaboration shall strengthen the development of Indonesian higher education, especially for the 8 leading indicators of higher education in Indonesia. We are also exploring a cooperation with Indonesian industries in various activities and actively involved in preparing the related government regulations. And recently, we have signed an MOU with Indonesia Telecommunication and Digital Research Institute, which is also known as the Telkom Corporate University in Learning, Research and Innovation, collaboration through publication, empowerment, and education that have a goal to develop Indonesia technology leadership, innovation capability, and digital talents. Next week, we will also celebrate the IEEE Day all around the world, celebrating that engineers meet the first time together in 1884. So we would like to encourage all of you to join us and enjoy all the activities. Ladies and gentlemen, in this occasion, I would like to express my gratitude to all of the committees who have worked very hard in preparing this high qualified IEEE conference. I'm very aware that putting together a conference of this size is not an easy task, especially this is 2 conferences together. Therefore, I sincerely hope for your cooperation and active participation in all of this conference program. I hope all of you will have an enjoyable and valuable experience during this conference event. And please share your best knowledge in your area of research and professional activities. Please stay active, stay healthy. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Hasbi, for the opening speech. The next agenda is the opening remarks from the General Chairs of IWBIS 2022, Dr. Insinyur Kuswardon, Professor
Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera. Honorary Rector of the Universitas Indonesia, Rector of Universitas Pertahanan Republik Indonesia, the Dean of Faculty of Computer Science, and the Dean of Defense Technology Universitas Pertahanan Republik Indonesia. Please allow me, on behalf as a General Chairs of the Organizing Committee of the International Conference on Advanced Computer Science and Information Systems 22, ICACSIS 2022, and the International Workshop on Big Data and Information Security 2022, IWBIS. We would like to give our warm welcome to our distinguished invited speaker, as well as all presenter and participant to this joint conference. We also thank to the Republic of Indonesia Defense University as the joint host of this event. This joint conference is organized by the Faculty of Computer Science Universitas Indonesia with the support of the Republic of Indonesia Defense University as joint host, especially the Faculty of Defense Technology, and the IEEE Indonesian section as the technical co-sponsorship. It is intended to act as a forum for sharing and exchange the idea for research and advanced application in computer science, information system, and also information security and big data. It is aimed to help researchers and practitioners gain inspiration for future research endeavors. Furthermore, it is offer excellent opportunity to broaden our understanding in a rapid advancing field. In this year edition of the joint conference, those opportunities are shared among members of the Indonesian research community and researchers from Indonesia, Philippines, Malaysia, China, Sri Lanka, India, Pakistan, Saudi Arabia, Japan, United States, Germany, Iceland, United Kingdom, Libya, Nigeria, Turkey, and Taiwan. Along with the 3 plenary speakers and 5 keynote speakers, this joint conference presents 60 papers over 2 days. Those papers have been selected from 100 papers from 15 different countries. We would like to express our sincere appreciations to the member of the program committee for the critical and constructive review of the submission. Their dedication to the review process reflect the level of quality being imposed on the paper selection this year. We thank to the organizing committee for their time and energy in preparing the event and giving us an excellent program for the conference. Our sincere appreciation also goes to many authors who have submitted their excellent work to the conference. We would like to extend our sincere gratitude to our rector of the Universitas Indonesia, rector of the Republic of Indonesia Defense University, and our Dean of the Faculty of Computer Science for their continued excellent support of the conference series. Lastly, we would like to thank this year host and all sponsor. We hope this year our conference is a success in facilitating further collaboration in the ever-expanding field of the computer science, information system, information security, and also the big data for better our society. Eko Budiarjo, the General Chair of the conference and workshop. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Professor Budiarjo, for the opening speech. Ladies and gentlemen, we will continue with the signing ceremony of Memorandum of Understanding between Defense Technology Faculty of the Republic of Indonesia Defense University and the Faculty of Computer Science Universitas Indonesia. The Defense Technology Faculty of RIDU will be represented by Dean Rear Admiral of Indonesian Navy, Dr. Insinyur Kasih Prihantoro, SI MM Terhan, and the Faculty of Computer Science Universitas Indonesia will be represented by Dean Dr. Insinyur Petrus Mursanto, MSc. We invite Rear Admiral Dr. Kasih and Dr. Mursanto to come to the stage for the signing, and we also invite Air Force Marshal Rudy Gultom, Dr. Ari Saptawijaya, Profesor Wisnu Jatmiko, Profesor Eko Budiarjo, Dr. Yugo Isal, Dr. Adila, Kolonel Ruby, Kolonel Royke, Colonel Lutfi, and Lieutenant Colonel Novki to come to the stage.
Pak Bambang, I think your microphone is still unmuted, still muted.
Thank you, Dr. Kasih and Dr. Mursanto and all participants. Please be seated, sir. Thank you. Ladies and before we proceed to the first plenary session, let us welcome a musical performance by Dr. Yugo Kartono Isal and Miss Penny Hutabarat. To Dr. Isal Hutabarat, the stage is yours.
Don't lose your way with each passing day. You've come so far, don't throw it away. Live believing, dreams of weaving, wonders are waiting to start. Live your story, faith, hope, and glory. Hold to the truth in your heart. If we hold on together, I know our dreams will never die. Dreams see us through to forever, where clouds roll by. For you and I, souls in the wind must learn how to mend. Seek out the star, hold on to the end. Valley, mountain, there is a fountain, washes our tears all away. What's us waiting? Someone is praying. Please let us come home to stay. If we hold on together, I know our dreams will never die. Dreams see us through to forever, as high as souls can fly. The clouds roll by for you and I. Terima kasih. Tanah airku tidak kulupakan, kan terkenang selama hidupku. Biarpun saya pergi jauh, tidak akan hilang dari kalbu. Tanahku yang ku cintai, engkau ku hargai. Walaupun banyak negeri ku jalani, yang masyhur pernah di kata orang, tetapi kampung dan rumahku di sanalah ku rasa senang. Tanahku tak ku lupakan, engkau ku banggakan. Thank you.
Thank you for the wonderful performance from Dr. Isal and Ms. Huta Barat. And everyone, all participants, please give a warm round of applause to our performers. Ladies and gentlemen, today we have a great panel of distinguished speakers who will be delivered two plenary speech and two keynote speech. And after the speeches, will be a time for discussion and with the speakers that will be moderated by ICACSIS and IWBIS general chairs, program chairs, and committee members. Before we continue with the plenary session, we would like to have another photo sessions, both here in the room from Faculty of Computer Science, Universitas Indonesia, and all panelists in the Zoom webinar. Okay, the operator, please stand by. The photo will be taken on my mark. 1, 2, 3. Another one. 1, 2, 3. And the last one with Salam Bela Negara style. Face your right hand in front of your chest. And on my mark, 1, 2, 3. Another one. 1, 2, 3. Okay, thank you. Ladies and gentlemen, as moderator of our first plenary sessions, we would like to invite Professor in Faculty of Computer Science, Universitas Indonesia, and also General Chairs of ICACSIS 2022, Professor Heru Suhartanto. Professor Suhartanto, the floor is yours.
Okay, thank you very much. Bismillahirrahmanirrahim. Assalamualaikum. Good morning. I think we met during your talk in Jakarta a few years ago. It's nice to have you here again, Professor Buyya. And then in this interesting keynote or plenary session, Professor Buyya is going to deliver his talk on neotric frontiers in cloud and edge and quantum computing. Can the organizing committee to display Professor Buyya's? Okay, hi, Professor Buyya. Nice to have you here again. Okay, he will be talking about neotric frontier in cloud and quantum computing. Just a short introduction from him because he's one of our distinguished guests and also the professor. He's a Redmond Berry Distinguished Professor and also Director of the Cloud Computing and Distributed System Laboratory at the University of Melbourne. He's also serving as the founding of CAO Manjrasoft, a spin-off company of the University, and commercializing its innovation in cloud computing. He also author over more than 850 publications, and also his index is 150. and is one of the highly chartered researchers for the 6 consecutive years. I think without further delays, I would like to invite Professor Buyya to deliver his presentation. Okay, Professor Buyya, it's yours now.
Hello, thank you for your kind introduction. I hope everybody can hear me. Okay, so let me thank all the organizers of this International Conference on Advanced Computing Information Systems, and providing me an opportunity to share some of my thoughts in advances that are happening in computer science to support varieties of application. So it is, of course, honor and privilege to be part of this conference and have university. So let me share my slide.
Okay.
Okay, I guess you can see my slides, correct?
Yeah.
Okay. So as our chair introduced me, that I'll be speaking on this recent cutting-edge research in cloud, edge, and quantum. Of course, so this research is driven by requirements of applications from big data and Internet of Things application. So therefore, whenever I speak about the technology, I will introduce applications from this domain to showcase how they are supporting, these technologies are supporting advances that are being made to support them. So before we go deeper into our discussion, so let's take a look at here are the some of the top technology trends for 2022 for this year. So begin with applied AI. Applying AI techniques to solve real-world problems. That's applied AI is very prominent, and that can definitely influence on the advances in computer technology and how we need to advance to support those applications. So next, our own focus of this keynote, this plenary keynote on cloud and edge computing, obviously driven by requirement of such applications, whether they are applied AI or healthcare applications. Then this quantum is just emerging more at the level of hardware, but this presents a huge opportunity for software people. So I like to present briefly some of our work in this area too. So you can see we are right on track in terms of technology trend that focus of this today's talk. With that, here is the outline. So I will quickly introduce you the emergence of computing paradigms, focus on this cloud, edge, and quantum. Of course, we'll also take a look at today's model of cloud computing and the applications and the new trends and how they impact on the architecture. So that brings to our market-driven cloud architecture. And I'll also discuss about one of our own technology called Aneka that allows you to build applications that can really harness the power of cloud computing to offer cost-efficient services. Next, we'll move on to IoT briefly and the requirements of those IoT, how they influence on computing. So that brings to new computing paradigms the recently introduced, such as edge and fog computing. So then we will take a look briefly at so one of our own effort called Quantum Function as a Service. So this is a software platform that we developed so that you can have access to quantum capability through cloud. So then we conclude at the end. So this is a brief outline of our discussion. So moving forward, as we know, so we had many advances and different computing paradigms introduced, both in computing space and communication. So this computing and communication, although in the past they have grown in parallel, but now there is a lot of convergence to support application. They need to work in synergy to enable new models, new paradigms to empower varieties of application. So this is just a quick glance from 1960 to 2030 in the future. And you will see we were having mainframe computers, but there was a vision to make access to mainframe computers as computing utility. So although that vision didn't happen, it took almost 40, 50 years for technologies to advance both in networking and computing, application services, where the point where, almost at 2010, we saw this emergence of cloud computing. So cloud computing as enabler for realization of the vision of computing as utility. So that was actually further, triggered by this notion of virtualization. So rather than having a physical server leased to consumers, we can lease a virtual machine, which means we can easily move the virtual machine from one place to other place, then consolidate or expand as necessary. So this way we can provide services based on the demand that is placed on those services by large number of users coming from all over the world. Now this IoT is about interconnecting physical and digital world in a seamless manner. So this IoT is another big trend. So as we progress very rapidly, so that the new model that is coming to support those real-time IoT applications. Then of course, quantum is growing for specific class of application, but these quantum capabilities are offered through cloud. So henceforth, we can further extend this cloud technology and also make quantum applications run easier. So these are some computing paradigms and associated issues. So these advances that we see in different computing models that are introduced, in the past, they were very heavily driven by big scientific applications and big military applications. But now they are driven by big population, so a large number of users. So these services that we host, ICT or application services, are consumed by large number of users worldwide. So this is the common man applications, healthcare application service, smart transportation service. These are benefiting the masses. So that is the focus as a result of recent requirement. Now the cloud, when we look at just briefly, you see, so this cloud offers various kinds of services that you can rent, lease, and then use it and pay for the consume. So utility model, just water utility, electricity, network, telephone networks. Similarly, computing as utility. So somewhere in network, all this capability, compute capability, like compute capability, application capability, to platform capability, these are available for you to lease. So these are meter service. So you as a user use them as a user from here. They use these services. They measure how much you're consuming. Accordingly, they charge you, and then of course you get the results and you pay for what you consume. This is the model what cloud has really introduced. Even though you might have subscribed to a service provider one, that doesn't mean that the service provider does everything for you. The service provider may be using service from others, like this different services, and put them together and delivering it. So this is how this aspect of multi-cloud, geographically distributed resources are used to deliver interesting services that common man can use. Now let's take a look at application. So during last 7-8 years, cloud has rapidly progressed and enabled many applications, which is very good news. So applications from traditional business, scientific application, so including, say, for example, the CRM, customer relation management, as a service that you can use if you have a company, a small scale company in Jakarta, for example. So a established company may have their own setup, but the small scale companies to set up such CRM just for a small beginning company, so with few customers, so it's not affordable to go for a old model, traditional model. So where you have to buy hardware, buy software, it must cost you, hundreds of thousands of dollars to set up. That is too expensive. Instead, you can move towards cloud where the service is available and use it and pay for what you consume. So this is how it is rapidly progress, which is success. Then coming to consumer world, we all use applications that are hosted in cloud regularly. For example, this micro mixing service Twitter is running on a cloud, so which we use very regularly, and also the people with like a Facebook account, social networking. So this Facebook is running on a cloud, geographically distributed. Then like that, cloud storage like Dropbox. So these are we are using every day. And then also this, for example, Zoom, which is a cloud-based video conferencing software. You see, there's a cloud-based service running, offering us so quick interconnectivity for our conference, for teaching, for meeting. So this is a big success that happened. So you can see we are already using any point most of the time, any common man are using it, which is the really success of cloud. Now, in terms of users that cloud supports, if you have an application such as, let's say, Facebook, at any point, more than 1.5 millions are using this at any point. So you can see huge number of requests here. Twitter, the same thing. E-commerce application running in the cloud. There are billions, millions and millions of transactions happening with huge spending just within a minute. So this is really what is happening with cloud-enabled services, that consumer services. So this is, you can say, cloud has become successful. Now, what about new technology trends? If you look at the previous, up to now, cloud was mostly virtualized, still virtualized, but what is rented to users is a virtual machine. But this virtual machine creation can take time. So creating a virtual machine sometimes takes a minute or 2 or 3, depends on scenario. So that is too much of wait time, latency. So to overcome the limitation, the concept of containers came into picture, and with that introduction of these microservices. So you have a application composed of small services, they're called microservices, and they can compose together dynamically based on the requirement. So that is what microservices are. And the virtualization of compute has extended further to a network. You can also virtualize the networks as well. So thus, if you have virtualized environment for mission critical application, you can dynamically allocate the required latency, required bandwidth, and also provide a better latency. So this is made possible through software networking. Then this blockchain, we are here more in the context of digital currency like Bitcoins. So this blockchain approach can also be used for creating trustable services. So in cloud environment, you are offering, let's say, healthcare services. Can we trust them? So because data from different devices is going to cloud environment, where from there, after pursuing results are coming back, we want to make sure that the results are trustable. So that is can be made through blockchain. So then, of course, AI, artificial intelligence, as we see, applied AI is the top trend, which means how can we extend this cloud technology to meet requirement of AI? So these are some of the new technology trends and application trends. Now, how do they impact on the architecture? Let's take a look at multi-rotate cloud architecture. So this is a little more deeper view of cloud environment. So in cloud computing environment, you have many servers that are called physical machines. You can see these are physical machines that are interconnected through network and which are SDN enabled software network. So then at the top we have users. These users have certain requirement, make a request to cloud environment. So based on user requirement, the system can see how much resource is there, how much is already allocated to others, and what is the requirement of the user. Based on that, it can create appropriate number of what we call virtual machine. So here is a virtual machine, for example. This virtual machine need to be ultimately mapped to a physical machine, to a physical server. So this process of mapping is also another challenging aspect. Develop an application structure, we need to decide where to place them. If you place them improperly, then they can introduce a lot of overhead, communication overhead, thus reducing the performance of your application and services. So that is the placement. So let's say somebody place this virtual machine on this server, on virtual machine you start running your application. With time, the demand on the application can increase. So initially maybe just 50 users. With the time it can become 500 users or 5,000 users. So when number of users increase, you also need to dynamically provision extra resource. So this extra resource that you provision can be within one location, can across multiple locations. If you have an application that is very popularly used by both Indonesia and Australia, so initially maybe Indonesia, you have resource in Jakarta. Later, if Australia also be a popular user of their application service, seamlessly we can expand and add few more resources from the Australia, and then application can distribute, then serve the user in Australia, Indonesia in a seamless manner. You see, this is then of course when the demand decreases, you reduce the resource that are allocated. Can be within one cloud or multiple cloud. So this concept is called elasticity. And as a result, we can achieve efficiency of resource. We can reduce the cost of computation. So here you see, we are only leasing what we need, when we need, and how long we need. So this has to be done dynamically. So autonomic principles. So we need to add appropriate dynamic resource allocation and reallocation techniques that can do this job. At the same time, we should also have applications that can harness this capability that we are provisioning from multiple locations. So that means application also have to be elastic. So how do we engineer those applications? Now let me discuss about technology that enables you to test dynamic provisioning and also elastic application creation to support such services. So that brings to one of our own technology called Aneka. So we call this as a Aneka. So Aneka is a cloud application platform. So this Aneka is a cloud application platform that we can use to build elastic application. So in my previous visit to Indonesia, Surabaya, Bali, and also Jakarta, I noticed this word Aneka is very extensively used in Indonesia. So sometimes you see in restaurants they write Aneka juices. That means multiple types of juices. So similarly here Aneka, we give name Aneka, which means it supports multiple models of programming. So this Aneka comes with a software development kit containing APIs and programming models such as thread model, task model, MapReduce. So what is unique about this model? I'm sure heard about thread programming in Java. So when you develop your application using Java threads, so let us say you have some hundreds of threads inside your Java application to support large number of users. When you are running that application on a server, you can primarily harness the number of cores inside that server. Say you got a 64 cores and it can run up to that. Maybe that can support say 100 users very easily, QoS requirement. What if number of users change from 100 to 10,000 users? That application won't be able to cope up because it can bind into only one server. Even if you had multiple servers, it won't be able to harness because Java thread can't expand behind a single server. So this is where Aneka threads come into picture, wherein Aneka threads can expand into across multiple servers that you lease, so to support large number of users. So that is made possible by the second runtime machinery, which is designed to scale out as necessary, scale in as necessary. So you can run it on those applications on a private cloud, or you can run it on a public cloud like Amazon, Azure, and so on. Or you can run across multiple clouds. So what makes this Aneka unique is that it has got a container-based architecture. So this is offering foundation services. These foundation services are extended to create task model, thread model, MapReduce. So you can see rapidly you can create those applications. And once you create them, you can deploy them in a private cloud or a public cloud in a seamless manner. So this is a way. This way you can make your application benefit and then deliver cost-effective services, but also they be elastic in nature. So when we look at the components, how Aneka operates, and you see here, there, for example, one side we have this deployment model, wherein dynamically these capabilities are provisioned, where Aneka is running, they become Aneka worker service, and they all work together to run your application. But before that, how is application composed? So here is for example, a simple task, say image processing. So in case of image processing, you have a cameras or videos, constantly video images are coming. When the video frames are coming and you want to analyze them rapidly so that you can get answer quickly. So first, here is a task for one of the image analytics. And this task you want to analyze across several images that you are getting. So that is where you can simply say, here is my, for n number of frames from 0 to n, so then I want to perform this task, correct? That's all you need to write. You have a logic and you say, I want to perform this for various scenarios. Then now Aneka will take care of dynamically provisioning and deploying these computations and distributing them, processing and providing results you in a timely manner. So this is how conceptually Aneka works. Now, I mentioned that Aneka also supports multi-cloud computing. Okay, so multi-cloud. So when we talk about multi-cloud, okay, we have adapted for different cloud environments. So that is because different cloud service providers have different access interface So as a developer of application, you don't want to deal with that. Instead, you can use these plugins that we have got. So that hides that complexity and the differences, heterogeneity of service success from end users. So we have adapted for Azure, Microsoft, Amazon, like that. If you set up one private cloud using OpenStack, you can use Aneka there also. Like this, multi-cloud computing is more easily enabled by Aneka. So that way we can benefit from real world requirement. Now, what is the application? How does this Aneka features helpful? Let me discuss those features in the context of applications. So these applications from big data and IoT. So you see, for example, from China, from India, we will discuss each of these a bit more depth. Then from Washington State University, in terms of deploying medical data analytics on a cloud. So when we have medical data analytics, we have privacy requirements. So for example, there are sensitive records, non-sensitive records. When you have sensitive records, you don't want to put it in a public cloud. You can use a hospital cloud. Non-sensitive can be sent to public cloud. Then applications from deep learning, and also this COVID-19 open research data set challenge. So this is a data challenge, and we can enable through Aneka to deploy on a cloud. We'll discuss those few of these in a bit more in depth. So here is the China Railways Corporation scenario of high-speed train design. They used to do rendering of this on a 4-port server using the software called Maya. So using the software called Maya, you perform. And this kind of operation to find out what is a suitable design that meets your requirement was taking anywhere between 24 hours to 80 hours. That is 1 day to 4 days. So if you want to reduce that time from 80 hours to say just 2 hours, you can set up for example, private cloud environment. This is done by that China Railways. And then we have a tool called Design Explorer. Using the Design Explorer, they're able to compose this application as a SPMD, single program multiple data, and run it on this private cloud. And by doing that, what took 80 hours, they're able to get answer in 2 hours. Here, Aneka-based cloud. This way, we can reduce the time to discovery. So productivity and discovery is faster. So now this is 2 hours. That is your local resource. Suppose if you have such a capability in your University of Indonesia, let's say it takes 2 hours. Next, sometime due to urgency, you might need result in 10 minutes. So therefore, you should be able to specify within this system. You can say deadline is equal to 10 minutes. Now you can define deadline. And then when we, in this case, we want to rent extra resource from a public cloud providers. So they all charge different price. So we want to restrict how much of money we spend to achieve this. So therefore, we can also put budget. Budget B is equal to maybe $5. So given a deadline and a budget constraint, the system is able to dynamically identify suitable resources that are affordable to your requirement, and then use them, and then pay for what they consume. Obviously, deliver just by this deadline of 10 minutes. So this is what makes Aneka very unique. So which is user requirements aware, resource management, and scheduling. Okay, so this is a very unique approach towards application engineering and the deployment. Then coming to the next one from ISRO Indian Space Research Organization. So here are the satellites regularly monitoring the Earth. Data comes to receiving station. So now you, for example, applications such as disaster management. So this is a disaster management application that's created using Aneka APIs. So, so the system is able to perform this computation, this big data computation within the local cloud environment. Sometime when there's a critical again, so they are able to use the resource from other locations of this organization. So this way we can further enable, a very interesting cloud computing. So that is, Aneka's approach to enabling cellular image sensing application. Now, let's move towards some kind of healthcare application. In healthcare application, so these are Internet of Medical devices such as, watches, body networks. We can monitor our bodily data, then vital statistics, and of course the data can be sent to a mobile phone. Then from there you can send a request to cloud environment. So where we have, for example, ECG. analysis as a service, ECG data analysis service running on Aneka, built on Aneka. Then of course Aneka can harness public cloud or private cloud. So this is the way, of course, after processing, you give back the result to the end user. Now, in case of healthcare being like this, so there are users with critical requirement. Somebody in emergency, they might say, please give me answers to my data that I captured, how I'm doing within a minute because of emergency. Other users, maybe not in hurry, they can say, give me answer in 24 hours just to see how my health is going, okay, how I should take care. So that is healthcare. So like this, the thousands of users, now we need to allocate and manage. So Aneka provides you that approach of autonomous management to meet requirements of users. So this is another interesting example of healthcare. This, we have put in practice. This is a snapshot of this connected that sensor to person hand. From there, we move to this mobile phone. From mobile phone, we send the request somewhere in the cloud, somewhere far away. We don't need to know where they are. So we use the resource and process and bring back. And you see, so it shows you very interesting results. So the results can be different purpose, how person should take care of his health, or what kind of food they should eat to, maintain, improve their health. So for example, so many simple healthcare application can be created, which is a potential use for a large number of users. So this is a real demonstration of the cloud and services and IoT integration. Now coming to AI, as you know, artificial intelligence has become very prominent and popular. So everyone is trying to extend their technology to support AI applications. So we also did the same thing. So for example, so there are AI, techniques such as deep learning. So this deep learning for object detection. So you want to detect object in a large number of images that are collected through these cameras and videos coming in. And so such application environment need to be first trained, that is a compute intensive. Then after training, do this rapid analytics. So let's say this data is coming to you. So here is the Aneka master to which the requests are coming in. So we this program called deep.py, the deep learning program written in Python. So this program we cloud enable using Aneka. As a result, so the different tasks of this one can run across multiple computation elements of Aneka within a cloud environment, within one private cloud, or you can dynamically provision extra from public cloud like Azure or. So this way we can analyze and then deliver results to the user. This is the interesting aspect of deep learning object detection. So here is an example of, for example, this is the laboratory environment with many computers. So this system is able to detect what all objects are there: monitors, keyboard, mouse, and so on. So then, of course, people, and if there's something missing, how many people are there? So very approach that can be used for quick detection and then enforcing any policy that you may have. So depending upon application requirement. So that is deep learning. So of course, another technique is machine learning. But before that, you see during last 2.5 years, more than 500,000 papers are published, research papers. And if you want to see what is the effective virus, what is the progression, what is the best vaccine that possibly suitable for latest variant of COVID. So going through all these 500,000 papers is not possible at all. So much of time consuming. And also, if you do analyze and classify and then rank them based on matching your requirement, then ranking on this laptop might take day. So going through those 500,000 papers and analytics. So to work up the limitation, we put together. So this COVID-19 code data analytics on cloud. So using machine learning and Aneka, you see here this the data set available. Then you can do some filtering. Then you put your data set in your local place or in a cloud environment. Then of course here using Aneka, a concurrent analysis of the machine learning task is supported. And then after that you can of course present the results in appropriate manner. So we have built a web program environment wherein you can filter out results based on your requirement. So this is work towards COVID-19. So here are the just high-level performance results. So for example, if you run it on a one server within cloud environment, it is taking something like 30 minutes. The same thing you can do it in just maybe 5-10 minutes in say multiple servers, say 4 servers. You can see 4 instruments of provision to meet the requirement of the deadline of say 6-7 minutes. But if you want to answer in 2 minutes, maybe further reduced by provisioning extra resource. So this is the way enabling. So this is an example of applying Aneka for machine learning tasks. We have done this for the context of COVID-19 publication development. This Aneka technology has been around. Latest version of Aneka is Aneka 5.0. So latest. So this one can download from our location and use and explore. Of course, this is a commercial product from Manjrasoft. So many people around the world are using this Aneka for different purposes. Coming to education, for example, in India, for instance, so numerous universities in India have set up cloud computing teaching, and they're using Aneka, and they have set up Aneka-based, cloud computing environment. So I'm using it for teaching courses in and offering hands-on experience. So this is across throughout India. So this is happening. So like this in China, in Europe, and other countries, people are using Aneka for teaching, for research, and producing interesting application, which we already discussed about applications. So, but now looking at teaching, so people can easily have hands-on experience on, programming, application programming for cloud computing. So now let us take a look at our IoT. So the moving from networks of computers, which is the internet, to network of everything that is called IoT. So this IoT, why is it so important? By 2030, right now just maybe 50 billion objects, but we see now it is 10 times more by 2030. So which means we need to relook about the way we create IoT application services. And then of course this also has a big business potential, and we can see, for example, IoT driven creation of smart world. Smart world means, say for example, smart healthcare, then smart transport, smart agriculture, then also driverless car. In future, in 10 years, 15 years time, we might have a driverless car. A car without a driver. Car comes, you get in, you tell, okay, please take me to from Jakarta city center to Indonesia University, which is away from Jakarta city. So the systems will take care of you. You can see the challenge of building driverless car. It requires a lot of automation, a lot of smartness, IoT capturing, then real-time decision making. So such things can enable. Now for such application, what kind of compute environment you need to have? So that brings to little extended thinking. The first classical model of IoT application enablement. So you can see IoT devices for different cloud environment. They tend to be, for the first version is, harness the power of cloud, then you get back the result. So this process was fine, but now moving forward with 100-fold increase in number of IoT, if you go for that model, it will push huge number of data into cloud environment. So network upload traffic can get clogged, and also the response time latency is very high. So in a smart transport, driverless car, you want latencies to be in microsecond, not in millisecond. Can be a problem because the vehicle is moving. So if it can't make a decision rapidly, so it can have accident also. So we need such real time. So for this purpose, the model of computing cloud come to the edge. So this is what is called edge computing. We use resources at the edge of the network to enable such application. Okay, in-car analysis, dynamically. Or sometimes you need not only edge, you also want to use this core network. Or you also want to use maybe on the cloud together, like this together. So this is called fog computing. These are the two models that are rapidly people are going to enable real-time application. That's the concept. Now, what about some software? So here is our own software framework called FogBus that we developed. This FogBus is a lightweight software framework for edge fog computing. It is also comes with blockchain. So we have implemented our own blockchain approach inside, which is again a lightweight, so that if any results are tampered, you can know. So here is the data, for example, healthcare oximeter data collection. So data goes to the app, and this app can send a request to the Fagbus resource manager. The Fagbus system service manager can actually see what services available at the edge of the network near to you, like Raspberry Pi, and use them most of the time. And sometimes you may have to use public cloud, so you can. This is done seamlessly. These are integrated and dynamically used. Then, of course, results after processing is done, results are back to the user. So this is how this system works. And you can put in practice in many areas, including healthcare. Of course, in healthcare, you can see health monitoring. Remote health monitoring is another prominent area, monitoring different aspects of our bodily activities, including ECG data, blood pressure, your fever level, and glucose, and so on. You can send them. Then after that, you can take appropriate action to improve your health. So here is the example of such application. We did it for sleep apnea analysis. So here is the oximeter. So you can connect to finger, the data collected, and data again comes to the healthkeeper app. And then, of course, the request is sent to an analyze. After analysis, here the result presentation. So in case of sleep apnea analysis, so the severity of that disease can be normal, mild, or emergency. If it is normal, no need to worry. If it is mild, no problem, slowly. If it is emergency, the person has to be rushed to hospital. Otherwise, if you don't do that within an hour or two, the person may die. Correct? So maybe requires specialist attention. So such quick analytics regularly can be very helpful. So here is such a thing we did. You can see we connected this oximeter to person finger, and data comes, and then of course analyze that, process the data. See, these are the Raspberry Pis. These are small Raspberry Pi. So the size of Raspberry Pi will be just like a small matchbox. So it will be just smaller than this box. Correct? You can just fix it at home. Right? You fix it at your wall at home. Then your data that are captured can be analyzed here on this Raspberry Pi box. See, that is a simple way. Then, of course, sometimes you need a interaction with the cloud, so that also can be done. So this is how you can put in practice. And of course, now coming to this blockchain, what is used? So the data that we are collecting here, so from this data is going to your local environment, may also go to cloud environment. So data is the time series data. You don't want someone tamper this result or data. If someone has tampered data on the way or results, then you can see blockchain is broken. If blockchain is broken, you can say, I can't trust this result anymore. So this is can be very helpful for for healthcare. So within our Fagbus breaker framework, we made it programming very simple. So as part of your application composition using Fagbus, you can just turn on flag. Blockchain is equal to true. That means it is enabled. That time there is a extra overhead in your service delivery, but it works because you are seeking trustful service. So here is my last example, and here you can see this is a drone-based networking system. So what these days people want to do something always with drone. So what can we do? So during this COVID-19, especially last year, there are lots of lockdown everywhere in many countries, including India and other places. So mainly in big cities, people live on multi-story buildings, towers, right? With 10 floors and 10, 20 different places, apartment people are living. When the lockdown occurs, so how to see health of how people are doing? So in India, we did this work of taking a drone. So let us say this is a moving drone, can move from one place to another place. And let us say this is a thermal camera. Okay, so let's say this thermal camera is fitted, and this is going around the building. So people were requested to come to, let's say, places like balcony. So it can sense the body statistics. Maybe if someone has a temperature similar to the COVID symptom. If so, we can recommend that person to isolate. So this is the data capturing, flying drones with a thermal camera. Then data comes to edge or a cloud where analysis is done. Then doctors can recommend maybe this person has a symptom, isolate and take care of himself. So recover, so not spread to others. So this is an example we did in the context of employing using drones and IoT, that is thermal camera. Then, of course, the solar is considered. Okay. So now this is my last part, very briefly, quantum function service. So first, please note, these quantum computing capabilities are available to users through cloud. So this is an extension of cloud service in a way. So therefore, we build a new technology called quantum function service, so which is a serverless-based framework for quantum computing. So before I discuss that, concept of quantum computing is more like, moving from our binary digital computers are 0, 1 bits, whereas in quantum, you can have n number of bits. A state can be represented through n, not just 0, 1. So for example, here, let's say you got 10 qubits, 2 bits, they call qubits, quantum bits. So 10 qubits, so you can have these many possibilities, multiple dimensions. Then these are the different input states, okay? So input, just like in binary, we have got inputs. So similarly also inputs. Then you can apply different gates, that gate, AND gate, OR gate, XOR gate. So apply these gates, create application. So this model of programming quantum application is very much like we used to program using digital, 50 or 40 years ago, very low level programming using AND gates, OR gate, and create a test bed, and using that test bed, you create application. Very, very basic way of programming. This is what is called quantum circuitry. This is application, for example, random number generation. Then the code wise, it may look like this, So you write it for IDM cascade. You do this same thing for Imagine bracket. You see the code is different. So if application developer has to worry about this low level circuitry programming and also translate different platforms, different code, this is too much of effort. So to reduce that, engineering effort, so we build this QFAS. So the aim of this QFAS is to simplify and automate the process of quantum development software. So this software development process simplification is the aim. So if you do through this low-level circuitry approach, it can be very cumbersome. So by going for some bit more automated system can be very helpful. And also you can solve problem of vendor lock-in. So because each of these quantum service providers, they have their own approach. So we don't want to build it for like this multiple approaches. We just want to build once, then dynamically, take care of the deployment across different environment. So this is the system. And also we want to support both classical, hybrid, and quantum. You want to compose your workflow application, for example, containing tasks that are quantum, tasks that are classical, or maybe mix up those two. So you compose that this will come to an ACAS environment. You compose that using our say templates, and after you compose, you send the request to this our QFAS application execution environment. So this system can see are these functions quantum, are they classical, are they hybrid? Accordingly, select the suitable resource. So suitable backend resource used to process your computation task. If it is quantum, quantum hardware will through cloud. So this is operational flow of that quantum application execution. As I said, this end users come to QFAS gateway, and then after composing application is given to this layer that takes care of execution. If it is a standard classical computation, run it on there. If it is a quantum, then you need to select appropriate backend. Backend can be as a IBM quantum or Amazon bracket or even the simulator. So like this, you can use and run seamlessly. So this is our very recent work carried out during last 7-8 months. We just about to release open source version of this QFAS so that other people can also benefit. Okay, so with that, let me conclude. So there are several computing paradigms of promise, the vision of how to make computing a utility. And here we got this cloud computing, so that enable this vision into reality. And already many exciting business and consumer applications are there, and we saw them briefly. Then, of course, with new trends, technology is rapidly emerging. And from that context, we discussed about this our Aneka as a cloud application platform, wherein you can engineer your application rapidly. So reduce the cost of software engineering. Then once you engineer the application, you can deploy on cloud environment with minimal cost and time. These are important cost efficient services delivery to consumers to meet their requirement. And we saw a few examples from China in engineering case. We saw some healthcare. We also saw this COVID data analytics. We saw AI applications like the detection. So currently there are many applications of ANECA. Then the first generation IoT, as I mentioned, they are pretty much cloud-centric. So moving further, the new generation IoTs, next generation IoTs would be edge or fog-centric. This way we can offer low latency services needed for real-time application. Then we briefly discussed about quantum. Quantum is essentially can be cloud or multi-cloud, given that this quantum services these days are available through cloud. And of course, when will quantum come to my laptop? Just like these days we got GPU, GPUs in our laptop. Can we have quantum in our laptop? So I asked the same question to a person from physics who works in SERE. He said, maybe next 20 years you won't have quantum processor in CPU in your laptop. Instead, you will have it in, of course, already in cloud. They will continue in cloud, and you can access it through these data centers. And which also means we need to advance the software also. And the state of the art of software for quantum computing today is very much like the software status 50 years ago during mainframe era. Very low level programming. So we need to shift from the low level simple complex programming to simplify. So therefore there is a lot of opportunity available to further advance this quantum computing software. So hopefully the future conferences will look into that. So in terms of future directions, there are many open challenges available. So this is a couple of experts put together this manifesto for future generation cloud computing, where we identified the strength and weakness of today's technology, then the open challenges and how we can advance the technology further during next 10 years or 8 years to make it much more powerful and mature from all angles. If you want to learn more about cloud computing and programming, application programming using ANECA, for example, so you can have this Mastering Cloud Computing book. So this is American edition. It might cost $100. No, I'm 100 American, so very costly. So for a country like India, so we have a low cost edition, it's simple, so which only costs $28. So very affordable solution. The same book can be, for example, exported to Indonesia by this Magrahil. Next, similar book we also have for Chinese. So this Chinese version is, just something like equivalent of $3. So it is very much affordable. And people often ask me, why is it so cheaper? Maybe this would be $4, half price of India. Right? Why is 3? The reason is that if you look at this text, Mastering Cloud Computing, you see this goes to 2 lines. The same text in Chinese, same font size is only 1 line. Right? 1 line. So that way the 500-page book became 300 pages. So because the programs in ANECA are still English, the rest of the text in Chinese is very compact. So this way, so it's more made affordable. So like this, one can have for different countries. So this is our IoT book, and this is our Edge for Computing book also. So we put together more as a edited collection. With that, let me stop here, and I like to thank all of you for hearing very patiently. Then of course here are my contacts. So those of you who want to interact with me for research, collaboration, visiting Melbourne University or studying Melbourne University, you can contact me using my Melbourne University email ID. Or if you want to set up, let's say, a cloud lab in your university or others who are attending, so please contact me using this my raj@manjrasoft.com email ID. So I'll be very happy to interact and explore with you. So with this, let me stop here. Then of course, if you've got any questions and comment, so most welcome. I think I have left another 5-10 minutes for possible interaction. Thank you again.
Okay, thank you very much, Professor Buyya, for very interesting talks. And we do still have about 10 minutes, and we have 2 questions at least from the audience. Let me. I think it is appear in the question and answer box. Can you read it, Professor Buyya? The first one is from Bobby Nasif. He said that Aneka reminds me of the Kandar system a long time ago. Does Aneka has scheduling algorithms to balance the computation load?
Yeah. So you're asking, does Aneka supports quantum?
Does it has scheduling algorithm to balance the computation load?
Yes. So within Aneka, we have two things. One is dynamically provisioning record resources. Okay. So this is in a cloud environment, you don't have a static collection of resources. You need to lease what you need. So that is called provisioning. So that is called dynamically provisioning based on requirement. So say for your application like that, we looked at say deadline of 10 minutes and budget of say $5. So there, so you need to find out how many resources are needed based on the workload requirement of that application at that time for a given deadline of 10 minutes. So let's say you need a 50 universal machine, you only have 25 in your office, you get another 50, another 25 other place. So that is called provisioning, dynamic provisioning. Once they're provisioned, so now we got this application task, they need to be distributed, they need to be scheduled on different, so that is called scheduling. So in Aneka, as I mentioned, our scheduling approach is aware of this QoS requirements of users, the deadline, the cost, budget requirement, and also they see what is the price of those services that you are renting from outside. So dynamically select suitably such a way that we can meet the deadline and the budget. So these are cost and time aware algorithms. So this, scheduling. So this is what we followed in Aneka to provide such time efficient, cost efficient services.
Okay, the next question is from Ejo Mandika. I think yes, it's still in. I think still open there. What is the best time to migrate our physical technology to cloud technology like Aneka Cloud, especially in the government organization area?
Yeah, actually, I also enabled this. Oh, sorry. Okay, so the QS. I was looking at chat room for questions. Okay.
In the QS.
So yes. Okay, I can see. Sorry, I was thinking why that question is not in the chat room. Okay, question answer data. All right. So what is the best time to migrate our physical technology to cloud? Like Aneka, especially government organization area. So is it affordable? The cost of the implementation, how much cost it may be, and monthly implementation. Okay. So first, you can actually move the existing application as is to cloud. So let's say you are running an existing application on one server, and rather than maintaining the server in your organization, you can take the application, rent a similar server in cloud and use it. Okay, so that is one simple way of migrating. But if you want to truly harness the power of cloud, where you can dynamically add, if there is a demand on your application very high, the server is not able to cope up with, so you can add other. So that requires maybe your application cloud enablement. Okay, the monolithic application won't benefit. Now, how can we translate this monolithic application to cloud enablement? One, you can use, for example, Aneka to cloud enable the application. Another, these days also, if the application is in Java, let us say, people are also coming out with this concept of microservices. So recently, some effort is happening where you can translate the Java code, source code, with classes into microservices. Then you run across and put them together. That's another second approach. So the third approach, within Aneka, we also have this tool called Design Explorer. If you want to run the same application with different data sets, like that China railway stuff, there you don't have to change your application. Also, you may not have a code to change the application. So you want to run that application for different scenario of analysis. That happens, for example, in drug discovery, or some investment risk analysis. Such application you can run single program, multiple data. So different data sets are fed in, but the same program running across multiple servers. And this is very easily enabled by Aneka. If you know Aneka technology, so within 10-20 minutes, you can compose such application in simple manner, for example. So depending upon application situation and the model choice, it can take anywhere between 1 hour to several days or months, depending upon approach you're taking to make your application truly cloud enabled. So obviously, there involve the cost of application engineering. Then after that, once you deploy, how much it costs to run it in cloud, similar to what you do in your local. So if you had to buy a server, you spend say $5,000. That server life is only 3 years. You can do the same thing in cloud. So what is the benefit? You don't need to worry about where the server is, management is powering, and all that. That responsibility you can shift it to cloud provider. Yeah. So it is all about shifting some of your responsibility to others. So this way you can focus on your core business. Now, like for example, to give our own example of University of Melbourne. So University of Melbourne, we used to have our own department email server. We used to have our own university server. First, we used to use our own, for example, Buyya CSSC email like that, my department email ID. Then university said, no, we don't want every department to keep your own email ID. Use the university one. Then we say Buyya. Then they started giving university service. Now they said, oh, we have to work so hard to maintain our data centers for so many users. Oh, this is too much of responsibility for us. Now they shifted it to, for example, Outlook server service offered by, Microsoft, and all our student accounts are shifted to Google. Now our people are not maintaining any server, not worried about anything. They're paying. So to do this, they were spending money to maintain the data center, money to maintain the air cooling system, the electricity power, and the people to manage it. That cost. Maybe you spend only 50%, you move it to somebody else. Is it advantage? It has certain cost advantage, but sometimes it has also problem. If somebody attacks that Outlook, you can be affected globally, correct? Or if somebody attacks the Google hosting service. So there are challenges. Yeah. So you have to see what is best in your scenario, and everything you might want to outsource. If there are some sensitive financial records, you don't want to put in a cloud. Correct? Otherwise, you are at mercy of those people. Email, okay, service outage, all right, you can get back. But if it is your sensitive data, so you are at the mercy of that global cloud. And then global cloud, it is likely that many people will attack if it is a big service. So this is a big issue on the data privacy. Not about privacy, also your integrity of your business. So some of them, maybe big corporates, will put such facility inside the organization, and they think, okay, we have control, we don't let anybody else come in. So maybe we have better sharing or protection of this, our capability and data and services. So accordingly, you have to choose. Few things you can actually outsource. In fact, this I also do. Even our Manjrasoft, we don't have our own server hosting or website. We just put it on cloud and rent it, and that's it. Pay $100, $200 per month, per year. Then instead of doing that same thing, and I can do it the same thing, but I have to worry about running and making sure that it is always working. Shifting responsibility, reducing cost, and the economy of scale will benefit.
Oh, there is a second question, I think, about the cost. I think the question, it is closed already. About the cost of implementation in Aneka. How does it compare with others?
Yes. So the cost of Aneka is, of course, a software technology. If someone is setting up a cloud environment inside their office, inside their university, so we work with the different upon university, we discuss and then provide. So we operate on their existing infrastructure. If they have network of computers, LAN connected, so they can just put Aneka there, they use it to solve it. Someone says, no, I want to set up more dedicated facility. Okay, you can do it. You can buy some servers from the market, then create a, say, infrastructure cloud, say OpenStack, then put Aneka on top. So depending upon user expectation, we give suggestion, then we give the Aneka software, and of course we give training on how to program it in case if they need. Otherwise, we made it very simple. Even the books are there, they can use.
Okay, very interesting. We would like to try Aneka to develop or to test our own clouds in University of Indonesia.
Thank you.
We let you know how the progress of it is. And once again, the time is up. We'd like to thank you again for Prof. Buyya for very interesting talks. And then hopefully we can see directly in the near future. Okay, thank you very much. Once again, okay, we would like to we give the time to the Master of Ceremony. Silakan, Master of Ceremony.
Thank you all. Thank you.
Thank you. Thank you.
Thank you. Thank you, Professor Buyya and Professor Suhartanto for wonderful and insightful speech and discussions. To all participants, please give a round of applause to the speakers and our moderator. Ladies and gentlemen, The next is we will have short break, and then we will continue with parallel session with several topics starting at 10:15 a.m. on Jakarta time. To all participants, please join your assigned room for your presentations, and to all participants, please join any parallel sessions that you are interested in. The link of parallel session can be found in the advanced program of both ICACSIS and IWBIS 2022. So, ladies and gentlemen, see you in the next sessions, and you can join on the parallel sessions on 10:15 a.m. on Jakarta time. Thank you.
In this digital age, information technology has become an integral part of human life. People use technology to facilitate all kinds of activities in various aspects of life, such as the economy, education, transportation, social, and health. Established under the name of Computer Science Center of Universitas Indonesia in 1972, the Faculty of Computer Science Universitas Indonesia is based across two sites, Depok, West Java, as well as Salemba, Jakarta, both located in the Greater Jakarta area. The faculty is the unique place for people who are curious and passionate about innovating and working in technology, especially in the fields of computer science and information systems. The fields of computer science and information systems are both related to technology, but there is a fundamental difference between the two. Computer science is about developing technical solutions for problems such as operating systems, algorithms, multimedia, information security, artificial intelligence, data science, and others. While the information system is about applying and integrating these technical solutions to address organizational or business problems. A computer science academic program is designed to include extensive knowledge in computer science, ranging from basic knowledge such as programming and how the computer works, up to advanced knowledge such as software engineering, artificial intelligence, and infrastructure and security. On the other hand, an information system academic program does not only include basic knowledge, such those studied under the Computer Science Study Program, but also the foundation in the fields of business administration and management, which help prepare students to develop, utilize, and manage information systems or information technology. The faculty has two academic programs at the undergraduate level, namely a Bachelor of Computer Science and Bachelor of Information Systems. For those who are interested in computer science, the faculty also provides an international undergraduate program in computer science with an opportunity to earn a double degrees in collaboration with partnering universities overseas. At the master level, the faculty offers a Master of Computer Science and a Master of Information Technology programs. For both of these master's programs, the faculty also provides an opportunity for students to complete them through a double degree with an international partner university. At the doctoral level, the faculty offers a Doctorate in Computer Science program, which has produced many leading scientists and researchers in the fields of computer science and information systems.
Faculty of Computer Science Universitas Indonesia has a vision as a center of excellence in computer science and information systems that is recognized by the international scientific community, well organized, and contributes significantly to increasing the competitiveness of Indonesia as a nation. To achieve our vision, we commit to implement three goals, namely excellent education, professional research and service, as well as the outreach programs.
As a nationally accredited institution, Faculty of Computer Science Universitas Indonesia is widely recognized as the leading academic institution in computer science and information systems. At national level, our students have been part of the Universitas Indonesia's team that has become the reigning champion in the largest ICT competition series for Indonesian students, locally known as Gemastik. The Universitas Indonesia's team has won the annual Gemastik 8 times, including 5 times in a row in 2016 to 2020. At the international level, the faculty also routinely gain notable achievements, such as at the 43rd Annual World Finals of the International Collegiate Programming Contest or ICPC, where Universitas Indonesia was ranked 21st in the world, tied with other top universities in the world. The excellence of education and research at the faculty is also recognized by various international ranking institutions. A recent ranking publication by Quacquarelli Simons World University Ranking by Subject 2021 places Universitas Indonesia at number 251 to 300 in the world in the fields of computer science and information systems. The faculty has a team of excellent teaching staff who graduated from various top universities in the world. Many of our professors or teaching staff are also leading researchers in their respective field. Equipped with strong pedagogical skills and educational background, our professors or teaching staff are ready to produce a new generation of experts in the fields of computer science and information systems. The faculty provides various amenities and facilities that can support the learning process and various student activities. Starting from a comfortable classroom, libraries with huge collections, spacious halls and auditoriums, computer labs, to advanced computing facilities such as a supercomputer, which is readily available at the Tokopedia UI Artificial Intelligence Center of Excellence. Our student body is a melting pot with best students coming from all parts of the Indonesian archipelago. These students take part in a rich tradition of academic activities, which include 2 flagship international scientific conferences held by the faculty every year, or other programs, such as the Teaching Assistantship or the Fellowship Program. Apart from academic activities, students are also encouraged to develop non-academic skills, which are accommodated by various student organization activities, such as the Student Executive Board and other student organizations or autonomous bodies. In addition, our students are also known for their ability to organize extraordinary events, one of which is the annual ComFest event, that is recognized as the biggest student-run event in ICT in Indonesia. This is in addition to other student communities or clubs, which provides an avenue for personal development in sports and the arts. Research and development is one of key activities at the faculty. Our staff and students are encouraged to produce works and solutions that address contemporary problems faced by both global and local communities. Our research contributions are not only in the form of basic and theoretical research, but also in application of various forms, ranging from software, information systems, to intelligence systems based on robotics and artificial intelligence. More than 6,000 alumni with a network spread across 7 continents. The majority of our alumni started working while still in university. While some of our graduates are employed in various companies and institutions, such as big tech companies in Silicon Valley, startups, consulting companies, research and education institutions, others have become entrepreneurs starting their own companies. Some of the companies founded by our graduates have been successfully acquired, listed on the stock exchange, and their founders have also been rewarded many prestigious international awards.
Wasikom UI menjadi bagian tak terlupakan dalam hidup saya. Ia seperti rumah kedua bagi saya. tempat di mana saya terbuka matanya untuk menjadi orang yang lebih baik dari hari ke hari.
Saya percaya di zaman-zaman kuliah itu sebetulnya pembentukan karakter, pembentukan mentalitas gitu. Dan UI itu is a very good place for me to have a good character.
Fasilkom UI telah memberikan saya banyak sekali ruang untuk mengembangkan diri, mulai dari pembelajarannya yang selalu mendorong untuk berpikir kritis, hingga kegiatan-kegiatan non-akademis seperti Kompes, panitiaan yang diadakan tiap tahun, dan juga organisasi-organisasi seperti BEM, Ristek, yang tak hanya meningkatkan soft skill saya, namun juga membantu saya mengeksplorasi passion saya dalam bidang IT.
By implementing the 3 duties of higher education or 3 Dharma, namely education and teaching, research, and community service, the Faculty of Computer Science Universitas Indonesia is at the forefront of producing the best graduate for Indonesia and the world.
Welcome to the Republic of Indonesia Defense University. The Republic of Indonesia Defense
In this digital
University,
age,
also known
information
as
technology
RIU,
has
is a
become
state university that organizes academic, vocational, and professional education in defense, national security. The vision of RIU is to become a world-class defense university in 2024 with research base that preserves national values. RIU was established and inaugurated on 11th of March 2009. At the beginning of establishment, RIU had 2 faculties, namely the Defense Strategic Faculty and Defense Management Faculty, which studied strategic national defense issues. On the basis of globalization, rapid technological change, constant change in circumstances, and the national defense facing dynamic threats, hence defense policy, analysis, and defense technology are needed to maintain the state existent, as well as supporting national defense. Therefore, in 2017, Faculty of National Security and Defense Technology Faculty were established by RIU. In order to support national defense, which is facing dynamic threats and significant changing era, in 2019, the Doctoral Program of Defense Science was established. The developments of the strategic environment, influences of globalization, and non-traditional problems which could erode the national defense are the reason why numerous threats occurred in all aspects of life, including the various diseases caused by viruses. Thus, these factors become the fundamental consideration for the Indonesian government at the end of August 2020 to initiate several bachelor degree programs in 4 faculties. Intending to empower and strengthen border areas and logistic needs, food security, and excellent human research, on August 30, 2021, RIU established a functional faculty. Currently, RIU has 3 campuses. The main campus in Sentul Bogor, the second campus in Salemba, Jakarta, and the third campus in Atambua, Belu, East Nusa Tenggara. In the area of research, students and lecturers of RIU conduct international systematic research in science and technology that utilize supercomputers, big data, and artificial intelligence. While in the area of community service, students socialize state defense and RDU programs by adapting futuristic Industrial Revolution 4.0 and Society 5.0 to digital technology utilizations which could be beneficial for both Indonesia and other nations of the world. In order to contribute to the development of defense science, RIU has been conducting numerous national and international seminars through academic and non-academic institution collaboration. These seminars bring together science and practitioners from world-renowned universities.
So far, studying in Universitas Pertahanan or Indonesian Defense University has been so interesting because the professors are actually supporting, motivating us to start thinking about what we're going to do for our thesis.
It is my hope that after graduation, I would have acquired extensive knowledge and skills, and of course, the Indonesian culture. I hope also that the information gained through the learning and teaching process will help me and my country design better disaster management strategies.
This university is very interesting to upgrade my knowledge. Also, I can learn Indonesia language, lifestyle, cultures, and at the same time, I can exchange my culture to Indonesians.
I started the doctoral program couple years ago, I think. Yeah, a couple years ago. So I believe that there is nothing too late to study, right? Honestly, it was long and very hard path to get here, but it was worth to have the class and sitting here with all my super colleagues in cohort 4 doctoral program.
Has earned the A accreditation by the National Accreditation Agency for Higher Education and is currently pursuing international accreditations. By 2024, our RDU attempts to obtain world-class defense university by instilling the spirit of national defense for a brighter future of Indonesia.
In this digital age, information technology has become an integral part of human life. People use technology to facilitate all kinds of activities in various aspects of life, such as the economy, education, transportation, social, and health. Established under the name of Computer Science Center of Universitas Indonesia in 1972, the Faculty of Computer Science Universitas Indonesia is based across two sites, Depok, West Java, as well as Salemba, Jakarta, both located in the Greater Jakarta area. The faculty is the unique place for people who are curious and passionate about innovating and working in technology, especially in the fields of computer science and information systems. The fields of computer science and information systems are both related to technology, but there is a fundamental difference between the two. Computer science is about developing technical solutions for problems such as operating systems, algorithms, multimedia, information security, artificial intelligence, data science, and others. While the information system is about applying and integrating these technical solutions to address organizational or business problems. A computer science academic program is designed to include extensive knowledge in computer science, ranging from basic knowledge such as programming and how the computer works, up to advanced knowledge such as software engineering, artificial intelligence, and infrastructure and security. On the other hand, an information system academic program does not only include basic knowledge, such those studied under the Computer Science Study Program, but also the foundation in the fields of business administration and management, which help prepare students to develop, utilize, and manage information systems or information technology. The faculty has two academic programs at the undergraduate level, namely a Bachelor of Computer Science and Bachelor of Information Systems. For those who are interested in computer science, the faculty also provides an international undergraduate program in computer science with an opportunity to earn a double degrees in collaboration with partnering universities overseas. At the master level, the faculty offers a Master of Computer Science and a Master of Information Technology programs. For both of these master's programs, the faculty also provides an opportunity for students to complete them through a double degree with an international partner university. At the doctoral level, the faculty offers a Doctorate in Computer Science program, which has produced many leading scientists and researchers in the fields of computer science and information systems.
Faculty of Computer Science Universitas Indonesia has a vision as a center of excellence in computer science and information systems that is recognized by the international scientific community, well organized, and contributes significantly to increasing the competitiveness of Indonesia as a nation. To achieve our vision, we commit to implement 3 goals, namely excellent education, professional research and service, as well as the outreach programs.
As a nationally accredited institution, Faculty of Computer Science Universitas Indonesia is widely recognized as the leading academic institution in computer science and information systems. At national level, our students have been part of the Universitas Indonesia's team that has become the reigning champion in the largest ICT competition series for Indonesian students, locally known as Gemastik. The Universitas Indonesia's team has won the annual Gemastik 8 times, including 5 times in a row in 2016 to 2020. At the international level, the faculty also routinely gain notable achievements, such as at the 43rd Annual World Finals of the International Collegiate Programming Contest or ICPC, where Universitas Indonesia was ranked 21st in the world, tied with other top universities in the world. The excellence of education and research at the faculty is also recognized by various international ranking institutions. A recent ranking publication by Quacquarelli-Simons World University Ranking by Subject 2021 places Universitas Indonesia at number 251 to 300 in the world in the fields of computer science and information systems. The faculty has a team of excellent teaching staff who graduated from various top universities in the world. Many of our professors or teaching staff are also leading researchers in their respective field. Equipped with strong pedagogical skills and educational background, our professors or teaching staff are ready to produce a new generation of experts in the fields of computer science and information systems. The faculty provides various amenities and facilities that can support the learning process and various student activities. Starting from a comfortable classroom, libraries with huge collections, spacious halls and auditoriums, computer labs, to advanced computing facilities such as a supercomputer, which is readily available at the Tokopedia UI Artificial Intelligence Center of Excellence. Our student body is a melting pot with best students coming from all parts of the Indonesian archipelago. These students take part in a rich tradition of academic activities, which include 2 flagship international scientific conferences held by the faculty every year, or other programs, such as the Teaching Assistantship or the Fellowship Program. Apart from academic activities, students are also encouraged to develop non-academic skills, which are accommodated by various student organization activities, such as the Student Executive Board and other student organizations or autonomous bodies. In addition, our students are also known for their ability to organize extraordinary events, one of which is the annual Confess event, that is recognized as the biggest student-run event in ICT in Indonesia. This is in addition to other student communities or clubs, which provides an avenue for personal development in sports and the arts. Research and development is one of key activities at the faculty. Our staff and students are encouraged to produce works and solutions that address contemporary problems faced by both global and local communities. Our research contributions are not only in the form of basic and theoretical research, but also in application of various forms, ranging from software, information systems, to intelligence systems based on robotics and artificial intelligence. More than 6,000 alumni with a network spread across 7 continents. The majority of our alumni started working while still in university. While some of our graduates are employed in various companies and institutions, such as big tech companies in Silicon Valley, startups, consulting companies, research and education institutions, others have become entrepreneurs starting their own companies. Some of the companies founded by our graduates have been successfully acquired, listed on the stock exchange, and their founders have also been rewarded many prestigious international awards.
Fasilkom UI menjadi bagian tak terlupakan dalam hidup saya. Ia seperti rumah kedua bagi saya, tempat di mana saya terbuka matanya untuk menjadi orang yang lebih baik dari hari ke hari.
Saya percaya di zaman-zaman kuliah itu sebetulnya pembentukan karakter, pembentukan mentalitas gitu. Dan UI itu is a very good place for me to have a good character.
Fasilkom UI telah memberikan saya banyak sekali ruang untuk mengembangkan diri, mulai dari pembelajarannya yang selalu mendorong untuk berpikir kritis, hingga kegiatan-kegiatan non-akademis seperti kompes, panitiaan yang diadakan tiap tahun, dan juga organisasi-organisasi seperti BEM, Ristek, yang tak hanya meningkatkan soft skill saya, namun juga membantu saya mengeksplorasi passion saya dalam bidang IT.
By implementing the 3 duties of higher education or Tridharma, namely education and teaching, research, and community service, the Faculty of Computer Science Universitas Indonesia is at the forefront of producing the best graduate for Indonesia and the world. In this digital age, information technology has become an integral part of human life. People use technology to facilitate all kinds of activities in various aspects of life, such as the economy, education, transportation, social, and health. Established under the name of Computer Science Center of Universitas Indonesia in 1972, the Faculty of Computer Science Universitas Indonesia is based across 2 sites, Depok, West Java, as well as Salemba, Jakarta, both located in the Greater Jakarta area. The faculty is the unique place for people who are curious and passionate about innovating and working in technology, especially in the fields of computer science and information systems. The fields of computer science and information systems are both related to technology, but there is a fundamental difference between the two. Computer science is about developing technical solutions for problems such as operating systems, algorithms, multimedia, information security, artificial intelligence, data science, and others. While the information system is about applying and integrating these technical solutions to address organizational or business problems. A computer science academic program is designed to include extensive knowledge in computer science, ranging from basic knowledge such as programming and how the computer works, up to advanced knowledge such as software engineering, artificial intelligence, and infrastructure and security. On the other hand, an information system academic program does not only include basic knowledge, such as those studied under the Computer Science Study Program, but also the foundation in the fields of business administration and management, which help prepare students to develop, utilize, and manage information systems or information technology, The faculty has two academic programs at the undergraduate level, namely a Bachelor of Computer Science and Bachelor of Information Systems. For those who are interested in computer science, the faculty also provides an international undergraduate program in computer science with an opportunity to earn a double degrees in collaboration with partnering universities overseas. At the master level, the faculty offers a Master of Computer Science and a Master of Information Technology programs. For both of these master's programs, the faculty also provides an opportunity for students to complete them through a double degree with an international partner university. At the doctoral level, the faculty offers a Doctorate in Computer Science program, which has produced many leading scientists and researchers in the fields of computer science and information systems.
Faculty of Computer Science Universitas Indonesia has a vision as a center of excellence in computer science and information systems that is recognized by the international scientific community, well organized, and contributes significantly to increasing the competitiveness of Indonesia as a nation. To achieve our vision, we commit to implement three goals, namely excellent education, professional research and service, as well as the outreach programs.
As a nationally accredited institution, Faculty of Computer Science Universitas Indonesia is widely recognized as the leading academic institution in computer science and information systems. At national level, our students have been part of the Universitas Indonesia's team that has become the reigning champion in the largest ICT competition series for Indonesian students, locally known as Gemastik. The Universitas Indonesia's team has won the annual Gemastik 8 times, including 5 times in a row in 2016 to 2020. At the international level, the faculty also routinely gain notable achievements, such as at the 43rd Annual World Finals of the International Collegiate Programming Contest or ICPC, where Universitas Indonesia was ranked 21st in the world, tied with other top universities in the world. The excellence of education and research at the faculty is also recognized by various international ranking institutions. A recent ranking publication by Quacquarelli-Simons World University Ranking by Subject 2021 places Universitas Indonesia at number 251 to 300 in the world in the fields of computer science and information systems. The faculty has a team of excellent teaching staff who graduated from various top universities in the world. Many of our professors or teaching staff are also leading researchers in their respective field. Equipped with strong pedagogical skills and educational background, our professors or teaching staff are ready to produce a new generation of experts in the fields of computer science and information systems. The faculty provides various amenities and facilities that can support the learning process and various student activities. Starting from a comfortable classroom, libraries with huge collections, spacious halls and auditoriums, computer labs, to advanced computing facilities such as a supercomputer, which is readily available at the Tokopedia UI Artificial Intelligence Center of Excellence. Our student body is a melting pot with best students coming from all parts of the Indonesian archipelago. These students take part in a rich tradition of academic activities, which include 2 flagship international scientific conferences held by the faculty every year, or other programs, such as the Teaching Assistantship or the Fellowship Program. Apart from academic activities, students are also encouraged to develop non-academic skills, which are accommodated by various student organization activities, such as the Student Executive Board and other student organizations or autonomous bodies. In addition, our students are also known for their ability to organize extraordinary events, one of which is the annual ComFest event, that is recognized as the biggest student-run event in ICT in Indonesia. This is in addition to other student communities or clubs, which provides an avenue for personal development in sports and the arts. Research and development is one of key activities at the faculty. Our staff and students are encouraged to produce works and solutions that address contemporary problems faced by both global and local communities. Our research contributions are not only in the form of basic and theoretical research, but also in application of various forms, ranging from software, information systems, to intelligence systems based on robotics and artificial intelligence. More than 6,000 alumni with a network spread across 7 continents. The majority of our alumni started working while still in university. While some of our graduates are employed in various companies and institutions, such as big tech companies in Silicon Valley, startups, consulting companies, research and education institutions, others have become entrepreneurs starting their own companies. Some of the companies founded by our graduates have been successfully acquired, listed on the stock exchange, and their founders have also been rewarded many prestigious international awards.
Fasilkom UI menjadi bagian tak terlupakan dalam hidup saya. Ia seperti rumah kedua bagi saya, tempat di mana saya terbuka matanya untuk menjadi orang yang lebih baik dari hari ke hari.
Saya percaya di zaman-zaman kuliah itu sebetulnya pembentukan karakter, pembentukan mentalitas gitu. Dan UI itu is a very good place for me to have a good character.
Fasilkom UI telah memberikan saya banyak sekali ruang untuk mengembangkan diri, mulai dari pembelajarannya yang selalu mendorong untuk berpikir kritis, hingga kegiatan-kegiatan non-akademis seperti kompes, panitiaan yang diadakan tiap tahun, dan juga organisasi-organisasi seperti BEM, Ristek, yang tak hanya meningkatkan soft skill saya, namun juga membantu saya mengeksplorasi passion saya dalam bidang IT.
By implementing the 3 duties of higher education or Tridharma, namely education and teaching, research, and community service, the Faculty of Computer Science Universitas Indonesia is at the forefront of producing the best graduate for Indonesia and the world. In this digital age, information technology has become an integral part of human life. People use technology to facilitate all kinds of activities in various aspects of life, such as the economy, education, transportation, social, and health. Established under the name of Computer Science Center of Universitas Indonesia in 1972, the Faculty of Computer Science Universitas Indonesia is based across 2 sites, Depok, West Java, as well as Salemba, Jakarta, both located in the Greater Jakarta area. The faculty is the unique place for people who are curious and passionate about innovating and working in technology, especially in the fields of computer science and information systems. The fields of computer science and information systems are both related to technology, but there is a fundamental difference between the two. Computer science is about developing technical solutions for problems such as operating systems, algorithms, multimedia, information security, artificial intelligence, data science, and others. While the information system is about applying and integrating these technical solutions to address organizational or business problems. A computer science academic program is designed to include extensive knowledge in computer science, ranging from basic knowledge such as programming and how the computer works, up to advanced knowledge such as software engineering, artificial intelligence, and infrastructure and security. On the other hand, an information system academic program does not only include basic knowledge, such as those studied under the Computer Science Study Program, but also the foundation in the fields of business administration and management, which help prepare students to develop, utilize, and manage information systems or information technology, the faculty has 2 academic programs at the undergraduate level, namely a Bachelor of Computer Science and Bachelor of Information Systems. For those who are interested in computer science, the faculty also provides an international undergraduate program in computer science with an opportunity to earn a double degrees in collaboration with partnering universities overseas. At the master level, the faculty offers a Master of Computer Science and a Master of Information Technology programs. For both of these master's programs, the faculty also provides an opportunity for students to complete them through a double degree with an international partner university. At the doctoral level, the faculty offers a Doctorate in Computer Science program, which has produced many leading scientists and researchers in the fields of computer science and information systems.
Faculty of Computer Science Universitas Indonesia has a vision as a center of excellence in computer science and information systems that is recognized by the international scientific community, well organized, and contributes significantly to increasing the competitiveness of Indonesia as a nation. To achieve our vision, we commit to implement 3 goals, namely excellent education, professional research and service, as well as the outreach programs.
As a nationally accredited institution, Faculty of Computer Science Universitas Indonesia is widely recognized as the leading academic institution in computer science and information systems. At national level, our students have been part of the Universitas Indonesia's team that has become the reigning champion in the largest ICT competition series for Indonesian students, locally known as Gemastik. The Universitas Indonesia's team has won the annual Gemastik 8 times, including 5 times in a row in 2016 to 2020. At the international level, the faculty also routinely gain notable achievements, such as at the 43rd Annual World Finals of the International Collegiate Programming Contest or ICPC, where Universitas Indonesia was ranked 21st in the world, tied with other top universities in the world. The excellence of education and research at the faculty is also recognized by various international ranking institutions. A recent ranking publication by Quacquarelli-Simons World University Ranking by Subject 2021 places Universitas Indonesia at number 251 to 300 in the world in the fields of computer science and information systems. The faculty has a team of excellent teaching staff who graduated from various top universities in the world. Many of our professors or teaching staff are also leading researchers in their respective field. Equipped with strong pedagogical skills and educational background, our professors or teaching staff are ready to produce a new generation of experts in the fields of computer science and information systems.
Welcome to the Republic of Indonesia Defense University. The Republic of Indonesia Defense University, also known as RIDU, is a state university that organizes academic, vocational, and professional education in defense, national security. The vision of RIDU is to become a world-class defense university in 2024 with research base that preserves national values. RIDU was established and inaugurated on 11th of March 2009. At the beginning of establishment, RIDU had 2 faculties, namely the Defense Strategic Faculty and Defense Management Faculty, which studied strategic national defense issues. On the basis of globalization, rapid technological change, constant change in circumstances, and the national defense facing dynamic threats, hence defense policy, analysis, and advanced defense technology are needed to maintain the state existent, as well as supporting national defense. Therefore, in 2017, Faculty of National Security and Defense Technology Faculty was established by RIDU. In order to support national defense, which is facing dynamic threats and significant changing era, in 2019, the Doctoral Program of Defense Science was established. The developments of the strategic environment, influences of globalization, and non-traditional problems which could erode the national defense are the reason why numerous threats occurred in all aspects of life, including the various diseases caused by viruses. Thus, these factors become the fundamental consideration for the Indonesian government at the end of August 2020 to initiate several bachelor degree programs in 4 faculties. Intending to empower and strengthen border areas and logistic needs, food security, and excellent human research, on August 30, 2021, RIDU established a fractional faculty. Currently, RIDU has 3 campuses. The main campus in Sentul Bogor, the second campus in Salemba, Jakarta, and the third campus in Atambua, Belu, East Nusa Tenggara. In the area of research, students and lecturers of RIDU conduct international systematic research in science and technology that utilize supercomputers, big data, and artificial intelligence. While in the area of community service, students socialize state defense and RDU programs by adapting futuristic Industrial Revolution 4.0 and Society 5.0 to digital technology utilizations which could be beneficial for both Indonesia and other nations of the world. In order to contribute to the development of defense science, RIDU has been conducting numerous national and international seminars through academic and non-academic institution collaboration. These seminars bring together science and practitioners from world-renowned universities.
So far, studying in Universitas Pertahanan or Indonesian Defense University has been so interesting because the professors are actually supporting, motivating us to start thinking about what we're going to do for our thesis.
It is my hope that after graduation, I would have acquired extensive knowledge and skills, and of course, the Indonesian culture. I hope also that the information gained through the learning and teaching process will help me and my country design better disaster management strategies.
This university is very interesting to upgrade my knowledge. Also, I can learn Indonesia language, lifestyle, cultures, and at the same time, I can exchange my culture to Indonesians.
IDU started the doctoral program couple years ago, I think. Yeah, a couple years ago. So I believe that there is nothing too late to study, right? Honestly, it was long and very hard path to get here, but it was worth to have the class and sitting here with all my super colleagues in cohort 4 doctoral program.
Earned the A accreditation by the National Accreditation Agency for Higher Education and is currently pursuing international accreditations. By 2024, our IDU attempts to obtain world-class defense university by instilling the spirit of national defense for a brighter future of Indonesia. Welcome to the Republic of Indonesia Defense University. The Republic of Indonesia Defense University, also known as RIDU, is a state university that organizes academic, vocational, and professional education in defense, national security. The vision of RIDU is to become a world-class defense university in 2024 with research base that preserves national values. Our IDU was established and inaugurated on 11th of March 2009. At the beginning of establishment, our IDU had two faculties, namely the Defense Strategic Faculty and Defense Management Faculty, which studied strategic national defense issues. On the basis of globalization, rapid technological change, constant change in circumstances, and the national defense facing dynamic threats, hence defense policy, analysis, and advanced defense technology are needed to maintain the state existent, as well as supporting national defense. Therefore, in 2017, Faculty of National Security and Defense Technology Faculty were established by our IDU. In order to support national defense, which is facing dynamic threats and significant changing era, in 2019, the Doctoral Program of Defense Science was established. The developments of the strategic environment, influences of globalization, and non-traditional problems which could erode the national defense are the reason why numerous threats occurred in all aspects of life, including the various diseases caused by viruses. Thus, these factors become the fundamental consideration for the Indonesian government at the end of August 2020 to initiate several bachelor degree programs in 4 faculties. Intending to empower and strengthen border areas and logistic needs, food security, and excellent human research, on August 30, 2021, our IDU established a functional faculty. Currently, our IDU has 3 campuses. The main campus in Sentul Bogor, the second campus in Salemba, Jakarta, and the third campus in Atambua, Belu, East Nusa Tenggara. In the area of research, students and lecturers of our IDU conduct international systematic research in science and technology that utilize supercomputers, big data, and artificial intelligence. While in the area of community service, students socialize state defense and RDU programs by adapting futuristic Industrial Revolution 4.0 and Society 5.0 to digital technology utilizations which could be beneficial for both Indonesia and other nations of the world. In order to contribute to the development of defense science, our IDU has been conducting numerous national and international seminars through academic and non-academic institution collaboration. These seminars bring together science and practitioners from world-renowned universities.
So far, studying in Universitas Pertahanan or Indonesian Defense University has been so interesting because the professors are actually supporting, motivating us to start thinking about what we're going to do for our thesis.
It is my hope that after graduation, I would have acquired extensive knowledge and skills, and of course, the Indonesian culture, I hope also that the information gained through the learning and teaching process will help me and my country design better disaster management strategies.
This university is very interesting to upgrade my knowledge. Also, I can learn Indonesia language, lifestyle, cultures, and at the same time, I can exchange my culture to Indonesians.
I started the doctoral program couple years ago, I think. Yeah, a couple years ago. So I believe that there is nothing too late to study, right? Honestly, it was long and very hard path to get here, but it was worth to have the class and sitting here with all my super colleagues in cohort 4 doctoral program.
Has earned the A accreditation by the National Accreditation Agency for Higher Education and is currently pursuing international accreditations. By 2024, our RDU attempts to obtain world-class defense university by instilling the spirit of national defense for a brighter future of Indonesia. Welcome to the Republic of Indonesia Defense University. The Republic of Indonesia Defense University, also known as RIDU, is a state university that organizes academic, vocational, and professional education in defense, national security. The vision of RIDU is to become a world-class defense university in 2024 with research base that preserves national values. Our RIDU was established and inaugurated on 11th of March 2009. At the beginning of establishment, our RIDU had two faculties, namely the Defense Strategic Faculty and Defense Management Faculty, which studied strategic national defense issues. On the basis of globalization, rapid technological change, constant change in circumstances, and the national defense facing dynamic threats, hence defense policy, analysis, and defense technology are needed to maintain the state existent, as well as supporting national defense. Therefore, in 2017, Faculty of National Security and Defense Technology Faculty were established by RIDU. In order to support national defense, which is facing dynamic threats and significant changing era, in 2019, the Doctoral Program of Defense Science was established. The developments of the strategic environment, influences of globalization, and non-traditional problems which could erode the national defense are the reason why numerous threats occurred in all aspects of life, including the various diseases caused by viruses. Thus, these factors become the fundamental consideration for the Indonesian government at the end of August 2020 to initiate several bachelor degree programs in 4 faculties. Intending to empower and strengthen border areas and logistic needs, food security, and excellent human research, on August 30, 2021, RIDU established a fractional faculty. Currently, RIDU has 3 campuses. The main campus in Sentul Bogor, the second campus in Salemba, Jakarta, and the third campus in Atambua, Belu, East Nusa Tenggara. In the area of research, students and lecturers of our IDU conduct international systematic research in science and technology that utilize supercomputers, big data, and artificial intelligence. While in the area of community service, students socialize state defense and RDU programs by adapting futuristic Industrial Revolution 4.0 and Society 5.0 to digital technology utilizations which could be beneficial for both Indonesia and other nations of the world. In order to contribute to the development of defense science, our IDU has been conducting numerous national and international seminars through academic and non-academic institution collaboration. These seminars bring together science and practitioners from world-renowned universities.
So far, studying in Universitas Pertahanan or Indonesian Defense University has been so interesting because the professors are actually supporting, motivating us to start thinking about what we're going to do for our thesis.
It is my hope that after graduation, I would have acquired extensive knowledge and skills, and of course, the Indonesian culture. I hope also that the information gained through the learning and teaching process will help me and my country design better disaster management strategies.
This university is very interesting to upgrade my knowledge. Also, I can learn Indonesia language, lifestyle, cultures, and at the same time, I can exchange my culture to Indonesians.
IDU started the doctoral program couple years ago, I think. Yeah, a couple years ago. So I believe that there is nothing too late to study, right? Honestly, it was long and very hard path to get here, but it was worth to have the class and sitting here with all my super colleagues in cohort 4 doctoral program.
Earned the A accreditation by the National Accreditation Agency for Higher Education and is currently pursuing international accreditations. By 2024, our IDU attempts to obtain world-class defense university by instilling the spirit of national defense for a brighter future of Indonesia. Welcome to the Republic of Indonesia Defense University. The Republic of Indonesia Defense University, also known as RIDU, is a state university that organizes academic, vocational, and professional education in defense, national security. The vision of RIDU is to become a world-class defense university in 2024 with research base that preserves national values. Our IDU was established and inaugurated on 11th of March 2009. At the beginning of establishment, our IDU had two faculties, namely the Defense Strategic Faculty and Defense Management Faculty, which studied strategic national defense issues. On the basis of globalization, rapid technological change, constant change in circumstances, and the national defense facing dynamic threats, hence defense policy, analysis, and advanced defense technology are needed to maintain the state existent, as well as supporting national defense. Therefore, in 2017, Faculty of National Security and Defense Technology Faculty was established by our IDU. In order to support national defense, which is facing dynamic threats and significant changing era, in 2019, the Doctoral Program of Defense Science was established. The developments of the strategic environment, influences of globalization, and non-traditional problems which could erode the national defense are the reason why numerous threats occurred in all aspects of life, including the various diseases caused by viruses. Thus, these factors become the fundamental consideration for the Indonesian government at the end of August 2020 to initiate several bachelor degree programs in 4 faculties. Intending to empower and strengthen border areas and logistic needs, food security, and excellent human research, on August 30, 2021, our IDU established a functional faculty. Currently, our IDU has 3 campuses. The main campus in Sentul Bogor, the second campus in Salemba, Jakarta, and the third campus in Atambua, Belu, East Nusa Tenggara. In the area of research, students and lecturers of our IDU conduct international systematic research in science and technology that utilize supercomputers, big data, and artificial intelligence. While in the area of community service, students socialize state defense and RDU programs by adapting futuristic Industrial Revolution 4.0 and Society 5.0 to digital technology utilizations which could be beneficial for both Indonesia and other nations of the world. In order to contribute to the development of defense science, our IDU has been conducting numerous national and international seminars through academic and non-academic institution collaboration. These seminars bring together science and practitioners from world-renowned universities.
So far, studying in Universitas Pertahanan or Indonesian Defense University has been so interesting because the professors are actually supporting, motivating us to start thinking about what we're going to do for our thesis.
It is my hope that after graduation, I would have acquired extensive knowledge and skills, and of course, the Indonesian culture. I hope also that the information gained through the learning and teaching process will help me and my country design better disaster management strategies.
This university is very interesting to upgrade my knowledge. Also, I can learn Indonesia language, lifestyle, cultures, and at the same time, I can exchange my culture to Indonesians.
I started the doctoral program couple years ago, I think. Yeah, a couple years ago. So I believe that there is nothing too late to study, right? Honestly, it was long and very hard path to get here, but it was worth to have the class and sitting here with all my super colleagues in cohort 4 doctoral program. Has earned the A accreditation by the National Accreditation Agency for Higher Education and is currently pursuing international accreditations. By 2024, our IDU attempts to obtain world-class defense university.
by instilling the spirit of national defense for a brighter future of Indonesia. Welcome to the Republic of Indonesia Defense University. The Republic of Indonesia Defense University, also known as RIDU, is a state university that organizes academic, vocational, and professional education in defense, national security. The vision of RIDU is to become a world-class defense university in 2024 with research base that preserves national values. RIDU was established and inaugurated on 11th of March 2009. At the beginning of establishment, RIDU had two faculties, namely the Defense Strategic Faculty and Defense Management Faculty, which studied strategic national defense issues. On the basis of globalization, rapid technological change, constant change in circumstances, and the national defense facing dynamic threats, hence defense policy, analysis, and advanced defense technology are needed to maintain the state existent, as well as supporting national defense. Therefore, in 2017, Faculty of National Security and Defense Technology Faculty was established by RIDU. In order to support national defense, which is facing dynamic threats and significant changing era, in 2019, the Doctoral Program of Defense Science was established. The developments of the strategic environment, influences of globalization, and non-traditional problems which could erode the national defense are the reason why numerous threats occurred in all aspects of life, including the various diseases caused by viruses. Thus, these factors become the fundamental consideration for the Indonesian government at the end of August 2020 to initiate several bachelor degree programs in 4 faculties. Intending to empower and strengthen border areas and logistic needs, food security, and excellent human research, on August 30, 2021, RIDU established a functional faculty. Currently, RIDU has 3 campuses. The main campus in Sentul Bogor, the second campus in Salemba, Jakarta, and the third campus in Atambua, Belu, East Nusa Tenggara. In the area of research, students and lecturers of RIDU conduct international systematic research in science and technology that utilize supercomputers, big data, and artificial intelligence. While in the area of community service, students socialize state defense and RDU programs by adapting futuristic Industrial Revolution 4.0 and Society 5.0 to digital technology utilizations which could be beneficial for both Indonesia and other nations of the world. In order to contribute to the development of defense science, RIDU has been conducting numerous national and international seminars through academic and non-academic institution collaboration. These seminars bring together science and practitioners from world-renowned universities.
So far, studying in Universitas Pertahanan or Indonesian Defense University has been so interesting because the professors are actually supporting, motivating us to start thinking about what we're going to do for our thesis.
It is my hope that after graduation, I would have acquired extensive knowledge and skills, and of course, the Indonesian culture. I hope also that the information gained through the learning and teaching process will help me and my country design better disaster management strategies.
This university is very interesting to upgrade my knowledge. Also, I can learn Indonesia language, lifestyle, cultures, and at the same time I can exchange my culture to Indonesians.
IDU started the doctoral program couple years ago, I think. Yeah, a couple years ago. So I believe that there is nothing too late to study, right? Honestly, it was long and very hard path to get here, but it was worth to have the class and sitting here with all my super colleagues in cohort 4 doctoral program.
Earned the A accreditation by the National Accreditation Agency for Higher Education and is currently pursuing international accreditations. By 2024, our IDU attempts to obtain world-class defense university by instilling the spirit of national defense for a brighter future of Indonesia. Welcome to the Republic of Indonesia Defense University. The Republic of Indonesia Defense University, also known as RIDU, is a state university that organizes academic, vocational, and professional education in defense, national security. The vision of RIDU is to become a world-class defense university in 2024 with research base that preserves national values. Our IDU was established and inaugurated on 11th of March 2009. At the beginning of establishment, our IDU had two faculties, namely the Defense Strategic Faculty and Defense Management Faculty, which studied strategic national defense issues. On the basis of globalization, rapid technological change, constant change in circumstances, and the national defense facing dynamic threats, hence defense policy, analysis, and advanced defense technology are needed to maintain the state existent, as well as supporting national defense. Therefore, in 2017, Faculty of National Security and Defense Technology Faculty were established by our IDU. In order to support national defense, which is facing dynamic threats and significant changing era, in 2019, the Doctoral Program of Defense Science was established. The developments of the strategic environment, influences of globalization, and non-traditional problems which could erode the national defense are the reason why numerous threats occurred in all aspects of life, including the various diseases caused by viruses. Thus, these factors become the fundamental consideration for the Indonesian government at the end of August 2020 to initiate several bachelor degree programs in 4 faculties. Intending to empower and strengthen border areas and logistic needs, food security, and excellent human research, on August 30, 2021, our IDU established a functional faculty. Currently, our IDU has 3 campuses. The main campus in Sentul Bogor, the second campus in Salemba, Jakarta, and the third campus in Atambua, Belu, East Nusa Tenggara. In the area of research, students and lecturers of our IDU conduct international systematic research in science and technology that utilize supercomputers, big data, and artificial intelligence. While in the area of community service, students socialize state defense and RDU programs by adapting futuristic Industrial Revolution 4.0 and Society 5.0 to digital technology utilizations which could be beneficial for both Indonesia and other nations of the world. In order to contribute to the development of defense science, our IDU has been conducting numerous national and international seminars through academic and non-academic institution collaboration. These seminars bring together science and practitioners from world-renowned universities.
So far, studying in Universitas Pertahanan or Indonesian Defense University has been so interesting because the professors are actually supporting, motivating us to start thinking about what we're going to do for our thesis.
It is my hope that after graduation, I would have acquired extensive knowledge and skills, and of course, the Indonesian culture. I hope also that the information gained through the learning and teaching process will help me and my country design better disaster management strategies.
This university is very interesting to upgrade my knowledge. Also, I can learn Indonesia language, lifestyle, cultures, and at the same time, I can exchange my culture to Indonesians.
IDU started the doctoral program couple years ago, I think. Yeah, a couple years ago. So I believe that there is nothing too late to study, right? Honestly, it was long and very hard path to get here, but it was worth to have the class and sitting here with all my super colleagues in cohort 4 doctoral program.
Has earned the A accreditation by the National Accreditation Agency for Higher Education and is currently pursuing international accreditations. By 2024, our IDU attempts to obtain world-class defense university by instilling the spirit of national defense for a brighter future of Indonesia. Welcome to the Republic of Indonesia Defense University. The Republic of Indonesia Defense University, also known as RIDU, is a state university that organizes academic, vocational, and professional education in defense, national security. The vision of RIDU is to become a world-class defense university in 2024 with research base that preserves national values. Our IDU was established and inaugurated on 11th of March 2009. At the beginning of establishment, our IDU had two faculties, namely the Defense Strategic Faculty and Defense Management Faculty, which studied strategic national defense issues. On the basis of globalization, rapid technological change, constant change in circumstances, and the national defense facing dynamic threats, hence defense policy, analysis, and advanced defense technology are needed to maintain the state existent, as well as supporting national defense. Therefore, in 2017, Faculty of National Security and Defense Technology Faculty was established by RIDU. In order to support national defense, which is facing dynamic threats and significant changing era, in 2019, the Doctoral Program of Defense Science was established. The developments of the strategic environment, influences of globalization, and non-traditional problems which could erode the national defense are the reason why numerous threats occurred in all aspects of life, including the various diseases caused by viruses. Thus, these factors become the fundamental consideration for the Indonesian government at the end of August 2020 to initiate several bachelor degree programs in 4 faculties. Intending to empower and strengthen border areas and logistic needs, food security, and excellent human research, on August 30, 2021, RIDU established a fractional faculty. Currently, RIDU has 3 campuses. The main campus in Sentul Bogor, the second campus in Salemba, Jakarta, and the third campus in Atambua, Belu, East Nusa Tenggara. In the area of research, students and lecturers of RIDU conduct international systematic research in science and technology that utilize supercomputers, big data, and artificial intelligence. While in the area of community service, students socialize state defense and RDU programs by adapting futuristic Industrial Revolution 4.0 and Society 5.0 to digital technology utilizations which could be beneficial for both Indonesia and other nations of the world. In order to contribute to the development of defense science, RIDU has been conducting numerous national and international seminars through academic and non-academic institution collaboration. These seminars bring together science and practitioners from world-renowned universities.
So far, studying in Universitas Pertahanan or Indonesian Defense University has been so interesting because the professors are actually supporting, motivating us to start thinking about what we're going to do for our thesis.
It is my hope that after graduation, I would have acquired extensive knowledge and skills, and of course, the Indonesian culture. I hope also that the information gained through the learning and teaching process will help me and my country design better disaster management strategies.
This university is very interesting to upgrade my knowledge. Also, I can learn Indonesia language, lifestyle, cultures, and at the same time, I can exchange my culture to Indonesians.
IDU started the doctoral program couple years ago, I think. Yeah, a couple years ago. So I believe that there is nothing too late to study, right?
Ladies and gentlemen, welcome back to ICACSIS and IWBIS 2022. For the next sessions in this afternoon, we will have our first keynote speech. And as the moderator of the session, we would like to invite lecturer at the Faculty of Computer Science, Universitas Indonesia, and also General Chairs of ICACSIS 2022, Adila Alpa Krisnadi, Ph.D. To Dr. Krisnadi, the time is yours.
Okay, thank you, MC, for the introduction. Good afternoon, everybody. Is my voice clear?
Clear, Pak Adila.
Okay, thank you very much. All right. So this afternoon for this keynote session, I will be your moderator. And in this session, we are very happy to have our distinguished speaker, Professor Mahardhika Pratama. Let me introduce him to everybody. Professor Mahardhika Pratama is an associate professor and enterprise fellow in AI at the STEM academic unit of the University of South East Australia in Adelaide, Australia. Prior to joining University of South Australia, Professor Pratama was an assistant professor at the School of Computer Science and Engineering at Nanyang Technological University in Singapore. And then before that, he was a lecturer at La Trobe University and a postdoctoral research fellow at the University of Technology, Sydney, Australia. He obtained his PhD from the University of New South Wales, Australia in 2014, an MSc degree from Nanyang Technological University in Singapore in 2011, and Bachelor of Engineering degree from Institute Technology School November, Surabaya, Indonesia in 2010. His research focus is in deep learning, including specific topics on continual learning, lifelong learning, incremental learning, stream learning, fuzzy neural networks, and intelligent control systems. In particular, the goal of his study is to develop a deep learning algorithm that can learn forever, as the case of biological learning. He has been he has published his works in many venues, including IEEE journals, AAA, CKDD, and other venues. And he also an associate editor in a number of journals. And he was recognized by the research community through several research awards, including IEEE PFS Prestigious Publication Award and 2019 MIT Research Award in Data Streams. So without further ado, I'll leave the time to Professor Mahardhika to deliver his talk on handling dynamic words with continual and autonomous machine learning. Professor Mahardhika, the stage is yours.
Thank you very much, Dr. Adila. First of all, I would like to, good day, everyone. I would like to thank Prof. Isnu, Prof. Adila for inviting me today, and other committee member for inviting me today. It is an honor to me to share our research work in the area of continual autonomous learning machine with you today. So perhaps I just share my screen. Okay, so the motivation of our work is that we want to handle a case where, as the human being, where we can learn forever. We as human being, we can learn forever. We can learn different tasks. We encounter different scenarios, different environments, dynamic environments, and so on. Particularly, first topic that I want to share with you today is about data streams. Many applications, we don't have a fixed data set. What we encounter is that we encounter the case where data are continuously generated, and we need to process those data in fast manner. Unfortunately, this data is not always stable. What I mean is that the distribution is not static, rather continuously change. How we can handle that? I remember 1 year ago, I also gave a talk to IWBIS, and I already talk about data streams. Now I'm not going to recount the same thing. What I'm going to talk about is our research work that we did recently. Okay, so just to remind everyone the challenges of data streams, unbounded continuously generated data. We need to process the data in a very fast manner, and as well as there is a problem of concept change or concept drift. In other words, the environment keep changing and our model should be updated as well. So it is not possible for us to retrain our model from scratch. And even say if a change happens, our model should adapt quickly to the new concept. We cannot, otherwise our model becomes inaccurate, meaning that we need to wait for enough data to be collected in order to retrain our model. And this is not convenient in practice. So we want to have a model that can adapt quickly to the new environment. Specifically, I'm going to briefly introduce work that we recently did that we call learning streaming process from partial ground truth. It is published in 2022 by IEEE Transactional Neural Network and Learning System. What happened is that here we want to address, we are interested to address the problem of domain adaptation. So say we have a source domain and we have a target domain, and source domain is labeled, but target domain is not labeled. Here we consider cross-domain case, meaning that the domain, source domain and target domain are different but related. In that case, the input space are different, but label space are the same. So if we talk about domain adaptation, it still require a lot of data. Oh, by the way, this is the problem of many data streams. Actually, it is the same with domain adaptation. The difference is just in many data stream problem, we don't have a fixed domain, rather than we have stream in the source as well as stream in the target. And we know in the data stream problem, there is a concept drift always, but because we have multi-stream here, data stream, concept drift in the source stream and concept drift in the target stream happen not in the same time. So how to handle with this problem? Now, if we talk about streaming case, meaning that the labeling process has to be affordable. It cannot be costly because we deal with continuously generated data. However, existing domain adaptation or existing many stream problems assume the source data streams or source domain are fully labeled, which is impractical, right? Because we want to have a model that have low label costs, low labeling costs. And we observe here, we use DAN. DAN is a domain adversarial neural network. This is state-of-the-art, very popular method in domain adaptation, And what happened is that when we reduce the label proportion of the source domain, the performance of the DAN drops significantly. Here we use 0.5, 50% label of the source sample, 40%, 30%, 20%, and 10%. And we can see that the performance actually drop with the decrease of labels. And it is not surprising, because if we go to the theory, we know that the generalization bound of the target domain is upper bounded by generalization the error of the source plus the distance between the source and the target. And in this case, if the model doesn't learn the source domain well, then the performance will drop. Now, how to handle with this situation? We assume that here we only have pre-recorded sample of the source domain. So when the streaming process continue, there is no label at all. So we rely only on initial label. And what is surprising is that when we have good label initially, we don't need to have fully labeled source string. So to handle with this stage, problem, we develop our method based on the clustering concept, deep clustering especially. So we have feature extractor, can be CNN and MLP, can be can be transformer, can be BERT, can be anything. And then we have layer 1, layer 2, until layer L, which are our fully connected layer. In every layer, we perform clustering, and then the output of each layer are aggregated to get the final score of our model. Now here, right, however, because we deal with many data stream case, so we should not only rely upon the we not only rely upon clustering adaptation. However, we need to also align the domain such that with knowledge of the source and unlabeled sample of the target, we can learn both domain equally well. So here we have feature extractor, and then here we have source stream, we have target stream, and and only first data batch are labeled in the source stream, and the rest are unlabeled, and target data stream also unlabeled. And here we have different but related feature space between the source stream as well as target stream. And then here we have feature extractor, which is CNN and MLP. And then here we use the concept of adversarial learning to align the domain. The principle of adversarial learning is that we have domain classifier that try to distinguish the origin of data sample, whether it comes from the source or whether it comes from the target, here. And then, however, domain alignment is achieved by gradient reversal layer. In other words, this feature extractor is trained such that to confuse the domain classifier, and at the end, domain classifier no longer be able to discriminate between source and target. At that point, then domain are already aligned. So the classifier that we have can be utilized to address the target data stream. And then here are our numerical result. By the way, we have two loss here, L cluster as well as L cross domain, which is adversarial loss. And this one is the clustering loss. And then we can see here, we compare our approach Leopard with ADCN, AECAMINS, DCN, DEC, DEN, and so on. And we find that our approach can produce improved result compared to these algorithms. And then this is the TSNE plot. You can see here that initially there is no clustering structure, but after the network is adapted, somehow we can see that the cluster according to the class can be visualized. Now, the problem that we talked about before is about data stream. Now we are going to talk about continuous learning. Continuous learning is different from data stream in the case that we handle multiple tasks. We not only handle a single task, okay? So meaning that we handle a sequence of streaming tasks. So in that context, we can see that human becomes increasingly smarter over time. Couldn't we build a similar system that basically learns forever? So what happened is that if we see the case of the baby, he or she learned the cat to recognize a dog, to recognize a cow and horse. And at the end, we as human beings have no problem to recognize all those objects. However, in neural network or any machine learning, they suffer from the problem of catastrophic forgetting. So meaning that only the last case are remembered while other are forgotten. So how to handle with this problem? Tasks are received in sequence. Total number of tasks is unknown, and at any given time, only the current task is accessible, meaning that we cannot accumulate all the samples that we have in the past and use it for training process of the current task. Knowledge is transferred from previously learned tasks, forward transfer, and current tasks should improve understanding of old tasks or backward transfer. So meaning that when we learn the current concept, our model should become better to recognize the previous concept, previous task, given if there is correlation between these tasks, and somehow there should be some correlation between the problem that we encounter now and the problem that we encountered before, as well as the forward transfer, the experience that the model get when it encounter the task. Then when learning a new task, it should be able to learn that task better. Now, challenges I already mentioned briefly: catastrophic forgetting, quick adaptation to new environment, computational and memory constraint. The total number of tasks is unknown because once again, we want to have our model to learn forever, so we don't know how many tasks we have. And ideally, it should be able to learn many tasks. But this is not easy. And if we talk about the image classification or computer vision case, there is a new instant problem, meaning that distribution of the data change, or there is a new class changing the class set with the same number of samples. However, this is old definition. We can always, recently people already talk about how to handle new domain. So meaning that, okay, I learned domain 1 and then go to domain 2, domain 3, and so on. So that is the development in the community. Now, if we talk about existing approach in this algorithm, in this area, we have regularization-based approach, we have EWC, SI, MASH, LWF, and so on. And we have memory-based approach, we have ER, GEM, HM, DGR, and so on. Architecture-based, we have PNN, DEN, and so on. So in other words, if we talk about memory-based approach, we store a small subset of previous samples and use it to learn the current task. The advantage is that strong performance, free of task ID or task boundaries, and disadvantage is that it requires memory. So meaning that we need to have memory in order to avoid catastrophic forgetting. However, this method is very powerful for continuous learning problem. I think to my experience, this is the best one compared to other two approach. And we have structure-based approach where we expand the network whenever it encounters a new task, and then we isolate the old parameters so that catastrophic forgetting problem doesn't occur. And the last problem is regularization-based approach, where what happens is that we regularize important parameters of the old task so that it doesn't learn the current task. And then other parameters that are not important are intended to cover the new task. However, this method, although it is fast and and as well as easy to implement, this method normally don't scale well for large-scale problem if it is not combined with other approach. The reason being is because, well, if we don't analyze intercorrelation between tasks, then somehow the memory complexity that we need should be higher in order to address a lot of tasks. So that is the reason. And that's why this inspired our work that we call ICANA, Intertask Synaptic Mapping. What happened is that for this method, it analyzed the intercorrelation between tasks. So if a task, if two tasks are similar, they can be handled, they can be learned by the same node. If they are not related, then that node should not learn this task. So that is a principle. So this is regularization-based approach. Okay, so in ICANA, we formulate task-to-task. We have task-to-task mapping and synaptic-to-task mapping. Task-to-task mapping analyze the correlation, intercorrelation between tasks, and synaptic-to-task mapping analyze whether the correlation between the current node to the task that has been encountered so far. And this is the analysis of synaptic-to-task mapping. We calculate the information gain and as well as the entropy. And then we can see how the node correlate to the current task as well as in previous tasks. And then we have task-to-task mapping to determine whether or not the current task is relevant to the previous task, so that we can assign a node to the correct task. And then we utilize this mapping to control the learning rate of our model, so that when the learning should be high when a node is relevant to the current task, and learning rate should be low when the node is not when the node is not related to the current task. So that is the principle. So in continuous learning, what happens is that we learn a stream of tasks, and at the end we evaluate the model with all the tasks that we have encountered so far. So we test our problem in split MNIST, rotated MNIST, permuted MNIST, and omnicloud. Split MNIST, meaning that we split overall MNIST problem into disjoint tasks. For example, task 1 is 0, 1, task 2 is 2, 3, task 3, 4, 5, and so on. And for rotated MNIST, for each task, we apply a random angle of the images. For permuted MNIST, we apply a random permutation in every image. And then in omnicloud, we apply split as well. So this one is a split omnicloud. We evaluate the performance of our model in terms of accuracy, backward transfer, and forward transfer, and compare with other memory-based approach as well as other approach. For example, TGR distilled, HM, this one are memory-based approach. And this is what we can report. For split MNIST, our method is not that better, is okay, it's comparable compared to other methods. But for permuted MNIST, we win significantly compared to other approach, and in the rotated MNIST comparable. But surprisingly, we get a good approach, a good performance when we learn omnicloud, because omnicloud has 50 tasks, whereas MNIST-based problem have 5 or to 10 tasks. So we can conclude that for large-scale tasks, for large-scale problems, this ICANA can provide a benefit. Well, you can see HM here is better than our method. Well, HM is memory-based approach, so this method need to keep the memory. So whereas our method doesn't have any memory at all. And this is our application study. When we remove the task-to-task mapping, the performance is compromised. So meaning that the task-to-task mapping is important for our case. Now, I already talked about continuous learning, and I already talked about data stream. The next problem that I want to introduce is online continuous learning. What happens is that when we learn a new task, we want to learn that task fastly. Assume that we combine online learning and continuous learning. So in that context, we not only learn various tasks, but we need to learn a task in online manner, meaning that every task has to be learned in a single epoch. No further epoch, just a single epoch. And once an epoch is done, a sample has been learned, it cannot be revisited. And this is useful for time-critical application, such as onboard processing. Learning a task has to be fast enough and doesn't impose heavy memory burdens. And this is another approach that we propose. We call it scalable adversarial online continual learning. And it has been recently accepted by ZML PKDD. And here, what happened is that we developed our framework from ACL, or adversarial continual learning. However, ACL is not yet designed for online continual learning setting. And it is quite expensive because for every task, it needs to have a different feature extractor. So say if we have 100 tasks, so we need to have 100 feature extractor, as well as adversarial game has to be played by multi-discriminator, the same with the number of tasks we have. So this one is too costly. But the good thing is that what we like with this approach is that because it decouple task-specific feature from shared feature. So we try to produce task features that are common, so they can be shared, and features that are specific, belong to specific tasks, can be extracted and put feature can be combined at the end for a classifier to predict, to do a prediction. And this is the approach that we do. We have feature extractor, we have parameter generator, and we have feature transformation, as well as we have classifier and discriminator. Now, for feature extractor, we don't have a task-specific feature extractor. Now, the question is that how we can generate a task-specific feature. What happened is that we have scaling and shifting parameter here, and we use feature transformation concept. So the shared feature are modified so that it becomes a task-specific feature. And after that, we fit that to classifier. And we have a single discriminator as well to produce a shared feature. So in other words, discriminator and feature extractor here is trained in adversarial manner to produce a shared feature, and parameter generator. And parameter generator here produce scaling shifting parameter to modify the shared feature into the task-specific feature. And this is fit to the classifier, and classifier produce the prediction. And this is the numerical result that we have. We test our methods for split mini ImageNet, split CVAR 100, permuted MNIST, split CVAR 10, and we can achieve improved performance compared to state-of-the-art approach. For example, CTN is published in ICLR 2020, very recent, and we can beat them with 1 or 2% accuracy compared to that method. However, we also evaluate the performance under different memory budget. And then what is what is the aspect that we achieve better significantly? Performance improvement is achieved in the context of execution time. For split CVAR 10, we are faster. For split CVAR 100, we are also 3 times faster. For split mini ImageNet, we are also faster than CTN and other algorithms. Now, we talk about unsupervised continual learning, where sample is only provided for every task. We only provide labeled sample initially, and then the rest of the sample are unlabeled. And the motivation is that most approaches are fully supervised in nature in continual learning, and most approach depend on the task ID, and most approach ignores intra-task variation. Most approach overly rely on the task boundaries. And this is what we have. We recently published this work at DCN and KRA for ICACSIS workshop, as well as IEEE and NLS this year. And similar principle with Leopard that I introduced before for domain adaptation, but here we learn streaming tasks, not the same, not multiple streams. And then we also have flexible MLP, network depth adaptation, network width adaptation, meaning that the network are self-adjusted so that it can allocate enough capacity to the problem that we want to encounter. And to adapt the width of the model, we use network significance methods that based on bias variance decomposition. And then we also have network depth adaptation to adjust the number of layers of the model so that the model can learn well. And then to avoid catastrophic forgetting, we utilize experience replay. So this is the loss function of our model. We have reconstruction loss, we have reconstruction loss in every hidden layer. And then we also have clustering loss. And this is combined to update our model. And for centroid-based experience replay, what happens is that not all samples are to be replayed. We are flexible, meaning that for every task, we know which sample have to be replayed, which samples should not be replayed, something like that. So this is the principle of the method that we propose, centroid-based experience replay, to reduce the memory burden of cost as well as the computational complexity. We did this for split MNIST, rotated MNIST, promoted MNIST, and CIFAR-10. So this problem is pretty challenging. And we benchmark our algorithm with state-of-the-art methods. For example, STEM here, this is published in ICACSIS 2021. And this is our numerical approach. In short, we can say that we are competitive compared to STEM. In some cases, we are much better, but in some cases, we are comparable. For example, in promoted MNIST, we are much better. For split MNIST, we are not that better than them. For split CIFAR-10, we are much better. And for rotated MNIST, we are comparable in the terms of task accuracy, but frequential accuracy, meaning that the accuracy in the current task, we are better than them. And this is the memory evolution. So as I mentioned before, the sample that we collect and the sample that we replay are different. So we can choose which sample we need to replay, which sample we should not replay. And the last method that I want to introduce is that for GCL, graph continuous learning. This has been accepted and this month, my student is going to present this paper in CIKM 2020. The idea is that this method is for graph, so it handles non-Euclidean data. Not only that, it applies structural learning concept as well and memory replay. However, the approach that we use to evolve the model is different from Gera and Artesian. Here we use reinforcement learning. So we have a controller here that we train in reinforcement learning manner using Q learning principle. And then this controller is going to decide whether we add hidden nodes or delete hidden nodes, add hidden nodes or delete hidden nodes. So this controller and main network are then are deployed to handle continuous learning problem. And this is what we achieve. We can see that compared to other methods, by the way, other methods in graph continuous learning mostly work for task incremental learning setting, but not for class incremental learning setting. So that's why that is the distinguishing aspect of distinctive aspect of our approach compared to other approach. Even in the task incremental learning setting, we are still better than them significantly. Here 71%, we have 80%, here 94%, here 92%, and so on. But we need to stress that here, we don't run the code of other algorithms in the same computational environment because they don't release the code. So we just compare with the reported result that they have. Okay, so conclusion, the self-evolving concept is one way to adapt quickly to change, but this is not the only way. We can, if you want to know more about how to adapt to change quickly, you can go to few short learning literature. meta learning is one of them. By the way, for ACL, the question, you may have a question, scale, the online continuing learning work that I mentioned. You may have a question, okay, how we can train parameter generator network so that it can produce correct scaling and shifting parameters. We train it in meta learning manner using under pi level optimization problem. So, meaning that we train both network, so we do utilize the loss of the main network to train the network of the parameter generator. So meta learning is one way you can utilize that in order to adapt fastly to the concept change. It doesn't guarantee an optimal network structure. Okay, so this one, self-evolving concept, what I say is that under data-driven approach. However, if we do that using reinforcement learning, somehow it still has some optimal property. Data-driven structural learning works only for simple network structure, hardly applicable for complex structures such as CNN, LSTM, or transformer, because the network structure for this kind of model are complex, and it is very difficult to determine right formula for us to grow or prune our network. This concept only works for simple problems, but are often failed for complex high-dimensional problems. Yes, the reason being is that it is too slow, and every time we need to add a new node, we can only add one node. So we cannot determine how many nodes we need to add in every time step when we need. So that is the problem. So that's why for high dimensional problem, normally we need to have further studies regarding to how many nodes we need to add or how many layers we need to add whenever we want to evolve the model. That's why in the community, there are concepts of neural architecture search, and you can utilize reinforcement learning, you can utilize evolutionary computation technique to evolve your model. However, this one is very costly. Okay, so I think that's all for my talk, and thank you very much for the opportunity. We'll leave the session back to the moderator. Thank you, and welcome for any question you may have.
Thank you, Professor Pratama, for the presentation. We have quite ample time for questions. Maybe just ask the audience, does anyone have a question? If you do, please put your questions on the Q&A box. I will read the questions and let Professor Pratama to answer it. Meanwhile, while waiting for this, let me start with my questions then. So this continual learning model is very interesting. I remember in the past hearing about this model developed by researchers in CMU, the NEL model, never-ending language learner model. So how does it compare to NEL, for example, Isyana?
I haven't, for never-ending learning that you mentioned, I haven't read that into details. However, what I know is that this is for NLP. That this one is for NLP, but we can always modify the method for NLP to the computer vision problems. However, what I say, Isyana is one method that explore inter-task correlation. So we can just decide, okay, for example, this node should be assigned to which task. For example, task 1 and 3, 1 and 4, something like that. So as a result, we can share the node. Because in the past, a method like EWC, it only determine For example, Note 1 is only for task 2. If it is important for task 2, then it doesn't learn another task. Something like that. Yeah.
So the task here refers to, is it something like, say, image classification versus object detection? Is it something like that, or is it something like more specific?
Well, ideally, it should be like that. Ideally, it should be like that. For example, I'm talking about image classification problem for task 1, and then we go to, for example, text classification problem for the next task. Ideally, it should be like that, but we, in the research community, we have not achieved that level yet. So we still assume that every task are different, but different in terms of different distribution, different classes, or different domains.
I see.
Yeah. For example, MNIST for task 1, USPS for task 2, and SVHN for task 3. So still in this level. Yeah.
So in this case, from something like we change the number of target classes, that would be already a modification in that sense. Right?
Yeah. For example, task 1 is 01, task 2 is 23, something like that. Yeah.
Oh, I see. Okay. I see. Okay.
Yeah.
All right. Okay. Audience, please put your questions on the Q&A box. I will read the questions. We still have time for discussion. Right. So meanwhile, so let me just move on a little bit on the next question. So so in the sort of a conventional machine learning model, there is one of the key assumptions is the IID assumption, right? So identically and independently distributed data. So obviously, with the shifting of the domain, this doesn't apply anymore. How do you exactly, work around this issue? Because if you don't have IID assumption, some simplification in the, for example, optimization could no longer be done, right?
Yeah, that's right. So this is exactly right. For example, in the many data stream problem that the first topic of my talk, we assume that source stream as well as target stream are not obviously have different distribution, and because it has different domain. For example, MNIST and USPS as a target, MNIST as a source. So what we need to do is that we need to extract shared features across these two problems. So if these two problems, we can share the features, then and train our network in that set space. In that case, we can learn both. We can address both problems. However, task-specific features are still important. That's why when we talk about ACL, we extract both cases, task-specific features as well as shared features case.
I see. So this is interesting when you move between tasks, right? I mean, you mentioned shared features in this case, but then you also consider the task-specific features. So, for example, if we move between the first task to the second task, my understanding is that the task-specific features of the first task will be somehow forgotten.
Yeah, that's exactly the challenge. Yeah, that's exactly the challenge. So when we learn task 2, we not only look at shared features, but prevent our model from forgetting.
So yeah, you mentioned catastrophic forgetting, so that means you don't want to forget too much. Is that
yeah, we don't want to forget what we already observed in the past. So that's why in the ACL or Isiana, if we want to talk about regularization base, in the ACL we have a memory. So we select a small subset of samples from the previous task when we learn the current task.
Okay, that's interesting. Right, so I'm still getting a question from the audience, but we have very interesting discussion here. So while we're waiting, let me continue with another questions that I think very interesting. Because in your slides, you mentioned that in real world, we seldom have completely labeled data, right? So we usually only have labels only for like small subset of the data. Now, when you usually in the for example, if we learn machine learning for the first time, we learn that to optimize the parameters, we use we supervise the change of the parameters based on the loss function between the target and the prediction, right? Now, how do you actually use the unlabeled target data in this case to guide the optimization?
So this can be done several ways. In our approach, we still utilize reconstruction loss. However, this is not the only way. We can, more advanced techniques like self-supervised loss. It is possible to be used as well. If we talk about self-supervised loss, we can have, we can train a model such that it perform one sample classification. So it maximize the distance between this sample with other dissimilar samples, and then minimize the distance between the intra samples or the sample that are relevant for that are similar to the current task. Yeah.
Thank you. So this is very interesting. I'm also like I find this is also interesting. Although my own sort of personal interest will be more on the text side of it instead of the image. But this is something that we could use as well for text.
Oh yeah. So for text, in fact, this is growing now and started. So yeah, I haven't explored that. So we still have. We still do it for images as well as graph. We are currently trying for time series. Yeah, but text will be interesting, and text may have similar characteristic to time series because it is sequence, right? We need to learn it in sequence.
Right. Thank you. So right. So do we have questions? Not yet. Okay, that's fine. I'll continue discuss with Professor Pratama here. So we have a right. So let's move a little bit to a more sort of practical issues in training this kind of model. Because you mentioned streams, I initially thought that we have sort of a source of stream data that gives you sort of a data points time-wise, like that continues forever or something like that. But now you use MNIST. How do you so in this case that means you treat MNIST data as a stream, or is it like, I mean, traditionally you would consider MNIST data as simply a set and then you put it all, right? But
no, so we treat MNIST, ImageNet or CVAR 100 as the stream. Especially for the online continuous learning setting, once we learn the sample, we assume that it is no longer available. So yeah, and also when we learn task 2, for example, we don't have any sample for task 1.
Wow. Okay.
So that's why catastrophic forgetting problem it will happen.
Right.
Yeah. So we purposely set the task disjoint so that we can evaluate how model behave for catastrophic forgetting problem.
I see. Okay. I see. Right. So now we have a question from the audience. Can this model be used for low resource data? I think this is very interesting as well, right?
Yeah, that's right.
Consider tasks where you have like already learned with the high resource data. Now you try to shift it to the low resource data. What do you think about this?
Meaning that low
resource, meaning maybe I'm not entirely sure how this works in image setting, but in NLP, for example, one could consider high resource language like English. You have a lot of data
Oh, I see.
And then you have Indonesian, for example.
Yeah, this is interesting, and this is something that we low resource means scarce sample, right?
Yeah.
That's right. So this is challenging problem, but we are currently working on the area of continual few shot learning. So what happened is that we have a lot of tasks, streaming tasks, and we have a base task, and then few shot tasks where we only have few sample. For example, 1 way, 1 shot, 5 way, 1 shot, meaning that we have 5 classes and only 1 sample per class. And we can also consider more extreme case where we have, scarce samples. So this is where the point I mentioned during my talk. If we want to adapt quickly with few sample, we need to go to few short learning literature, because this is where people address short sample problem. So if say, because this is practical, say in real life, when condition change from condition 1 to condition 2, and at the same time we are considering streaming case, we don't have all data available at once. So in that context, a model has to be trained fastly so that it can adapt to task P or condition P in very fast manner, right? Yeah, but we are trying to do it now. It is still ongoing. But one way to address this is, there are several ways. Yeah, later on perhaps once we have the result, we can share with you. Yeah.
Thank you, Dr. Pratama. So we have a time for one more question.
Adila, can I give some maybe a simple question maybe, because
yes, go ahead, Prof. Vishnu.
Yes, thank you, Mas Dr. Adila, and thank you, Mas Dr. Mahardhika, for very interesting explanation about the AI and implementation. But I just want to maybe please maybe you can give the share how you maybe choose the topic, because I think the topic is quite similar and continuously. For example, you explain 2 or 3 topics for the maybe your student or your group, and how to maybe guarantee maybe the topic is become, I don't know, it's become different with another researcher, and how to guarantee become maybe good publication. Maybe you can share to the audience. Maybe we can learn from Dr. Mahardhika. Thank you.
Yeah, thank you very much, Prof. Vishnu. Well, as a scientist, we need to accept that the research that we do is not rocket science research. As a scientist, we understand that the research that we do is always incremental. We try to work with a problem and try to give our innovation for that problem. For me, we work in the area of continual learning, and we try to come up with different problems, because this is the easiest way. So for example, if we talk about to the best of my knowledge, autonomous cross-domain adaptation under extreme labor scarcity that we explained in the first topic of my talk, this is not yet considered. So for us, we always look at new problem and try to propose a solution, because once if we do it that way, it is easier to say be distinctive from others. And second is competition, because if we say there is an established problem and we work on that, we have so many competitors and we have so many state of the art, and we want to publish a paper, say, or produce a work, we need to beat them. If there are so many works already in that topic, it is difficult to get recognition or to get for our work to be read by others, because there are so many options. So we always start with a new problem. We try to start with a new problem. We don't say that this is totally new. For example, I shared with you about continual few short learning. There are some works already here, few works already here. But there are not many, so we try to jump to that direction. Or if possible, totally new problem. One problem that may be not considered so far is like the problem of weak label. This is something that we have not considered. Weak labels, say the label that model learn. We still have a label, but the label is weak, meaning that it is not necessarily representing the ground truth. So in that case, we can jump and propose a solution for that. Yeah. To guarantee how it is different, yeah, we assume that the problems that we do, and when I allocating the task to my research student, there should be a roadmap, because for the thesis, because a thesis is not independent chapter, say, there should be a bigger problem when this research is done, what we can accomplish. And this should tell a story. So that's I think what we do. Yeah.
Maybe additional question maybe, because I just want to maybe learn from Dr. Mahardhika. How about when we choose the new topic, for example, and there is maybe no one, maybe another researcher, maybe even maybe simple or little difference. But sometimes, because I don't know, when we jump to a new topic, we must have some background about the topic and how to maybe, maybe, for example, your research team to maybe to bridging the gap about the new topic. Any maybe any good experience from you maybe?
This is my opinion. It is better to be a leading researcher in a particular field rather than doing research in too many areas. So we have 1, 2, 3 topics that we have, and try to lead in this area. So that's what I suggest, because you say I'm doing computer vision and I'm doing totally different thing. It will be different. It will be difficult for us to lead that area. What I do is normally for research student, for the first few chapter, I drive them, but for the following chapter, normally I let them independent, because at the end he or she need to be independent researcher. Yeah.
Okay. Thank you.
Yeah.
Thank you, Prof. Wisnu Jatmiko, for the question as well. Prof. Mahardhika Pratama, thank you very much for the talk. I think it's very inspiring with new areas to explore, and hopefully somebody gain some interest to this area. And right, so everybody, let's give a round of applause to Professor Mahardhika Pratama for the talk and the insightful discussion.
Thank you very much, Dr. Adila, Prof. Adila. Thank you very much, Prof. Wisnu, for the invitation. And I would like to thank all the committees for inviting me today to share several pieces of books that we do. I hope it is useful, or if you have anything to discuss with me, welcome.
Okay, thank you very much.
Thank you.
All right, so I guess we come to the end of the session for this keynote speech by Professor Mahardhika Pratama. I thank everybody for joining us in the session and for your attention and participation. So thank you very much, and I'll give the time back to the MC. Thank you, and see you in the next session.
Thank you, Dr. Mahardhika Pratama and Dr. Adila Krisnadi, for insightful discussion this afternoon. Please give a round of applause to our speakers and our moderator for these sessions. Ladies and gentlemen, we will continue our agenda today. The second keynote speech that will be moderated by the lecturer in Faculty of Computer Science, Universitas Indonesia, and also Program Chair of ICACSIS 2022, Dr. Yugo Kartono Isal. Dr. Isal, the time is yours.
Okay, thank you very much, Hafiz. Good afternoon, everyone. Now it's time for us to have another keynote speech that will be delivered by Dr. Jonni Mahroza. Probably I have to say something about a brief summary about his education background. Pak Jonni graduated from Indonesian Military Academy in 1989. Okay, and then he took some political science subject and international relation while he was working or starting to work in the military career, and he got his Ph.D. in defense studies from Flinders University in Australia, and then also another degree which is national security strategy. That's the topic, from National War College of National Defense University in Washington, D.C. And also, Dr. Jonni has experience as a defense attaché in London and also as a non-resident defense attaché in Kingdom of Sweden and Denmark. And he is currently the Vice Rector for Academic and Student Affairs in Republic of Indonesia Defense University. Okay, I think without further ado, let us listen to the keynote speech will be delivered by Dr. Jonni Mahroza. Pak Jonni, the time is yours.
Thank you, Mr. Moderator, Mr. Yugo Isal.
Yes.
Let me share my screen. Can you see my screen? My PowerPoint? Is that okay? Yeah, first of all, thank you very much for the opportunity for delivering this keynote speech. It's really an honor for me. As mentioned by the moderator, I'm not an expert in AI, but I'm going to talk about AI from the perspective of security studies, strategic studies. So the title that I would like to talk about is the roles of artificial intelligence.
Sorry, Pak Jonni, we cannot see the slides.
Oh, you cannot see the slide. Okay, something coming up with the. Let me share it again. Is it okay now?
Yeah, it's clear now.
Okay, thank you.
Okay.
Yeah, I'm going to talk about the roles of artificial intelligence in warfare, cybersecurity, and cyber defense. So probably I'm just going to talk about this AI in general and general perspective. So I admit, because I'm not an expert in AI, so I'll ask very technical questions at the end of this presentation. Some key points I would like to talk about is the transformative power of AI. And then I'm going to talk about AI as an existing threat, AI and the art of warfare, application of AI in the military field, autonomous and robotic weapons, AI, malware, and cybersecurity. And I'm going to talk about AI and cyber weapons, AI and information warfare, malicious AI attacks, swarming attacks. Let me start with the first point with the introduction. Cyber has continued to grow and expand in a movement of expansion that nothing seems to be able to stop. It has transformed the world to the point where it has reached the status of a new dimension alongside the land, the sea, the air, and space. Since then, this expansion has been motivated as much as by the scientific as by economics and industrial motives, as well as by political issues. The recent technological markers of these developments are, for example, big data, cloud computing, 4G, 5G, the Internet of Things, IPv6, and social media. At the political and social level, the manifestation of this expansion can be seen by access to the internet, which affects an ever-growing population by digital societies and economies that are increasingly dependent on networks, the internet, computers, and communication tools. So the concept of artificial intelligence, or AI, reappeared around 2015. AI is an element of cyberspace, one of the driving force behind this broad movement of continuous expansion. AI is already present everywhere around us in all our daily life without us being aware of it most of the time. In this speech, I will try to understand how AI has been integrated into defense strategies, and more specifically into cybersecurity and cyber defense. The integration of AI into the fields of security and defense is the result of a decade-long process and is still rapidly growing. The next point I'd like to talk is with the transformation power of AI. AI has given rise to years-long debates and controversies in philosophical, political, sociological, economic, historical, and ethical and legal aspects. Everyone agrees that the transformative power of AI is central. Everybody seems convinced that AI will have an impact on all human activities. It is still too early to measure the magnitude of these effects, even though AI is not new and has existed for many years through various applications. At present, the transformation is still deemed positive. It is considered as an advantage, an added value, and a progress. Transforming AI in all fields will definitely also have effects in the fields of security and defense. Scientists are affirmative that AI will revolutionize the art of war. Therefore, it is interesting to think about how the latest generation of AI and its new promises of technological progress will revolutionize security and defense policies in strategic or operational fields. In this respect, AI will have major involvement in the transformation and revolution of military affairs. The cyber domain in particular will be impacted by this role of AI, designed especially to operate in the fields of cybersecurity and cyber defense. Let me move to the next slide about AI and its existing threat. The first level of AI threat lies in the creator's loss of control of the machine. This argument has been present since the early years of AI. In 2014, Stephen Hawking and Elon Musk raised this argument again, claiming that true AI could bring about the end of humanity. This statement was not new and is part of the years-long debate on the impacts of the AI technology on humanity. One of the first objects of controversy lies in the recognition of or denial of possible equivalence or even superiority of AI over humanity. Autonomous weapons, which is weapons controlled by AI rather than human, already exist for quite some time. Hundreds of scientists and experts have urged the UN to develop a new way to protect humanity from the risk involved in autonomous weapons. Many governments worldwide already have access to various AI control or semi-AI control weapon systems, like military drones. For example, with facial recognition software, a drone can track an individual. It is disturbing to realize that we start allowing AI algorithm to make life and death decisions without any human input. It is also possible to customize consumer technology like drones to fly autonomously and perform various tasks. This kind of capability in the wrong hands could impact the life of many people anywhere and anytime. Now, let me move to the next slide, the next point about AI and the art of warfare. The contribution of AI to the military materialized at several areas. For example, in the application of information technology in warfare, such as radar system, radio networks for control, command and communication, navigation, guidance devices for missiles. AI make these applications smarter in line with the progress achievement by AI and integrates them into a defensive and offensive weapon system. The introduction of AI has an impact on the military and the art of warfare. In particular, it promotes decentralization of military operation. AI research is evolving toward a model of control based on dispersed decision-making, a model that could be used to promote decentralization within the military. However, it can take a long time between the emergence of technology and their full integration into the military and warfare. Our experience shows that the full-scale tactical integration of new technologies into the military has always been a long process. Expert systems are the most successful implementation of the AI in the military to date. For example, the 3 applications of AI that the Pentagon wants in expert system are battle management advisor, cockpit advisor, and autonomous weapons. One of the obsessions of the military commands is removing the human elements from the battlefield and removing the soldier from the decision-making loop. For example, the Pentagon has put forward defense research and development projects to create autonomous weapon system capable of fighting alone. The next point that I would like to discuss is the application of AI in the military field. AI now finds applications in a wide range of domains, which include design of an underwater robotic system for underwater mine detection and anti-submarine operation. It also includes intelligent drones to monitor borders and identify potential threats, or target recognition using machine learning to automatically locate and identify targets using synthetic and aperture radar or SAR images. And also C2 and C3I decision support in all levels, strategic, tactical, and operational. And also the identification of terrorist propaganda on the internet. It also includes enhancement of threat monitoring and situation awareness using surveillance, recognition and intelligence, or SRI systems, and development of AI embedded equipment such as surveillance drone. We can also see these include AI directed guns and missiles. And sometimes we also can include military healthcare systems and battlefield medical assistance using robotic surgical system or RSS and robotic ground platforms. We can also see this includes self-driving military vehicles or UAV control system, AI embedded combat platforms which are less dependent on human actions, and also weapon system capable of carrying out attacks in a collaborative manner. And of course, cybersecurity, military computerized systems are exposed to cyber attacks for which development of AI could eventually counter more effectively than human action of current cybersecurity system. With regard to logistics and transport, the use of AI could help to optimize this function and also reduce cost, shorten lead times, and detect anomalies and manage by greater anticipation. And also we can include combat simulation and training tools. So many can be included in this application. Let me now talk about the autonomous and robotic weapons. We must not confuse unmanned weapons with autonomous weapons, which are not remotely controlled. Robots in the forms of drones, namely the Predator's drones, returned to warfare practice in the 1990s, with the use in the Balkan War in 1995, which was made possible with the advance of GPS. In 2000, the era of the combat drones, in 2000s, the era of the combat drone took a new turn with the use of attack drones in Afghanistan in October 2001, which resulted in the killing of Mullah Omar, a leader of the Taliban. Other robots, notably mine clearing robots, were used in the Iraq War by the American. This robot would then be equipped with a weapon. The new American combat doctrine aimed to use as many as automated combat systems as possible, including fully autonomous weapons. In 2008, 12,000 robots were being deployed by the US. The global market for military land robots could reach around 10 billion US dollar by 2021, which is big money. However, the intelligent AI robot is vulnerable on several levels, just like any other devices or contemporaneous object. For example, in particular, on its material and physical dimension, it can be the object of attacks and physical destruction. It is also primarily dependent on its electric and energy sources. On its computational dimension, the input data can be altered or hacked. The algorithm can be fooled. The algorithm is not error-free or free from bugs, so it's also vulnerable. On its communication system, is very clear, very obvious. It can be jammed when you do the operation. Okay, ladies and gentlemen, the next point I would like to make here is about AI, malware, and cybersecurity. Cyber war is the expression of the armed conflict in cyberspace dimension. AI is a new aspect, which is new component and an integral part of cyberspace. Therefore, AI also contributes to the expansion of cyberspace, which in fact is a subset of information space. Sorry. For example, AI proves useful in navigating an environment that is too complex to be dealt with by conventional means. On the cybersecurity side, AI is then considered as the solution to the problem of cyberspace complexity. On the attackers or the hacker side, AI is the solution to the problem that might be resistant or the defense of the system to be attacked. But we also know that the complexity of cyberspace does not really benefit security, since there are many vulnerabilities hidden in the complexity of the cyberspace. Therefore, for cybersecurity, AI should not only help to detect attacks early enough, but also to unravel the cyberspace complexity in order to improve cyber defense and protection against the attacks. Nowadays, AI would be able to create the malware used in cyber attacks or analyze the situation in the same way as a human hacker would. In this way, AI would analyze and then model the behavior of the target's environment in order to go unnoticed, as not to provide any suspicion to the target's detection system or even to individuals observing, monitoring, or even targeting its operation. Let me move to the next point about AI and cyber weapons. In cyberspace, there are software tools that are designed to destroy or cause damage, such as the Stuxnet warn and other tools that are not created to contribute to offensive operations, such as the ping command, but nevertheless can be used by aggressor and criminals as part of the offensive actions. The development of offensive and defensive instruments in cyberspace by the military is one facet of the militarization of cyberspace. The deployment and use of these cyber weapons is part of this militarization. It is in this context of the use of cybernetic weapons by a variety of actors, either state or non-state, AI has recently emerged to open the way to new capabilities. The world's leading military powers are in the process of developing AI applications for an array of military functions. However, the prospect of autonomous AI enabled weapon system will probably be deployed not on the physical battlefield, but in cyberspace. Firstly, AI enables cyber capabilities based on deep learning algorithms will be easier and cheaper to develop than AI-enabled offensive autonomous platforms, which require mobility function to maneuver or fight physical enemies, especially if doing so entails deployment in a swarm formation. Secondly, given that most cyberspace operations remain highly classified and many armed forces still regard them primarily as auxiliary tools to support kinetic operations within the individual services of those armed forces, there will probably be less institutional resistance to developing and deploying AI-enabled cyber capabilities, as they do not appear to undermine prevailing operational concepts and organizational structure. Now I'm going to move to AI and information warfare. AI can be used in the information war as it can provide tools to help manage the mass of information. Even rudimentary applications such as the SIFT software or Stanford information filtering tool make it possible to filter and search for specific information in the masses of data posted by Usenet user. AI aims at bringing the computer up to the level of human intelligence and to surpass the reasoning ability of human. Information warfare, which plays on the level of knowledge, representations, reasoning, is a priori one of the major fields of AI application. AI software application offer the possibility of sending messages without knowing the recipient's address, with the software taking care of searching for the information and delivering the message. Furthermore, the prospect, especially for the military application, is also to make a significant progress and then to offer tools to help military commands to manage and to cope with big data. AI can also be deployed for IT infrastructure security. However, progress still needs to be made to develop smart firewalls and to monitor the activities of system user by learning about their habits, behaviors, and working environment, and also to assess the level of security using AI agents specializing in tasks to assess the security level of password authentication and the authorization. The next point I would like to talk is about malicious AI attacks. Sorry. Considers a scenario in which fraudulent emails are spread by spam phishing. But these emails are in fact driven by AI. Due to AI, each of these emails can be adapted to its target. So it is inserted into the flow of legitimate emails automatically, from which nothing or almost nothing will distinguish it, which will make identification and detection by classic cybersecurity tools very difficult, if not impossible. The usefulness of AI in malware is here to make illegitimate emails appear legitimate. This form of attack by impersonating a legitimate person already exists in some ways, including identity theft. But with AI, the maneuver can be carried out only automatically, and the attack can even become transparent. In this case, AI exploits its ability to pretend to be something it is not. So for AI, generating credible content that looks like human-made content is not difficult. In social media, for example, messages written by humans are generally short with only a few characters and sentences, and purely argued with no complex reasoning. Sometimes the spelling is also simplified or uses symbols or abbreviations which AI can easily learn. The last point that I would like to talk about is a swarming attack. The prospect of linking drones together in a very large number to launch them against target is made possible by AI. In this case, those many drones become a single unit, like a single body, of which each drone is part of the whole, and which can evolve and adapt its form and power to strike the target in such a way that the target can be quickly overwhelmed. Armed and fully autonomous drone swarms are future weapons of mass destruction. While they are unlikely to achieve the scale of harm as the hydrogen bomb or most other major nuclear weapons, swarms could cause the same level of destruction, death, and injury as the nuclear weapons used in Nagasaki and Hiroshima. That is tens of thousands of dead. This is because drone swarms combine two properties unique to traditional weapons of mass destruction: mass harm and a lack of control to ensure the weapons do not harm civilians. Experts in national security and artificial intelligence debate whether a single autonomous weapon could ever be capable of adequately discriminating between civilian and military targets, let alone thousands or tens of thousands of drones. Some scientists believe that such a weapon might be able to make that distinction within 50 years, Others believe that lethal autonomous weapons may one day prove better at reducing civilian casualties and property damage than humans. But that day has not come yet. AI in drone swarms cannot yet manage the complexities of the battlefield, but it is just a matter of time until AI will finally reach the cognitive intelligence required to fully in control of any battlefields of complexity. So, in conclusion, the implementation of AI in its cyberspace domain depend on many other aspects, such as speed, autonomy, infeasibility, action, decision making, big data, and etc. With the implementation of AI in the complex cyberspace, we must also be aware of its flaws and vulnerabilities, such as errors, biases, imperfections, and exposures to attacks, which are also among the most important aspects of AI. AI has been identified as one of the new forms of cyberspace. It is regarded as a transformative, disruptive, and revolutionary technology, but it has only recently been taken into account at political, strategic, and doctrinal levels. The new wave of AI is only in its infancy. AI, like cyberspace, appears to be indispensable to power in war. It is considered essential in building victories in wars. That's all I can say in this keynote speech. Thank you for your attention.
Okay, thank you, Dr. And we still have about 23 minutes for question and answer session. And I think Pak Adila in the chat has already write his question. So probably you better speak it yourself, Pak Adila. Thank you.
Yeah, hello. So my question is on the information warfare. In the context of information warfare, so we have state adversaries and non-state adversaries. How do you compare the threat of these two? The state adversaries would be kind of obvious, right? Like possibly enemy country that is enemy with us, or whereas non-state adversary maybe some third party who performs attack to our cyber system, for example. So in the context of these two kinds of adversaries, which one, or how do you compare these adversaries? Which one is more threatening, or are the threats different in terms of the characteristics? Could you probably elaborate a little bit more on this?
Okay, that is a very good questions. Thank you for your questions. So I'm going to answer your question from a very general overview of this comparison between our state adversary and non-state adversary regarding with the information warfare. As I think we understand, the almost all country experience this kind of information warfare, including our country, Indonesia. I think about information warfare. mostly if we talk about state advisory, I think we can compare. Let me think about. I mean, we can only compare the effects of the threat to the targets. It's quite difficult, I think, to compare between the methods or the infrastructure or the means that they're using for threatening the targets, because in the end, whether it's military or non-military, whether it's conducted by a state, a certain state to attack another state, or whether it's used by or conducted by non-state actors, or business communities, or other forms of non-state advisory, I think it's quite difficult to compare the in terms of the methods, the infrastructure, the means, and the tools and instruments. But you can only see, I think, in terms of the effects that they create or they resulted in of the threat, or for the military side, I think we can see how, for example, the use of information technology within the platforms of the military, whether it's for land, sea, and air, or cyberspace, how they can impact in the use of these equipments. But for the non-state advisory, I think you can use in many public and public facilities like banking system, hospitals, information system, telecommunication, and so on, energy, water, and so on. I think it's quite difficult. I mean, but in the end, the effects would be the same. The targets are the information technology or the information system of the targets that are being attacked. So unless you have a very good monitoring detection system, so far I think it is very quite difficult to see, especially for the public facilities. You can blame, for example, who can kill General Suleiman in Iran by using drone with the with the AI system. But by connecting it to geopolitical environment, by connecting it into something beyond technicality of technology, but it's not easy. I mean, it's quite difficult. Your question is very good, but I think it's very difficult to answer it. I don't know if it satisfies you. Maybe you have an opinion or comment about that one? What do you think?
Well, I myself don't know much about the actual situation. What I understand is that non-state actors would probably target more on the non-military systems instead of the military systems, like banking or energy or transportation. So I remember a few years ago I visited Singapore and they showed us um, kind of system to protect their water because they got water supply from Malaysia, uh, and this water supply is very critical to the livelihood of everybody in Singapore. So if you attack the water system, then well, you don't need to attack the military bases. You attack the water system, and without that everybody couldn't live, right? And I would think that the non-state actors would sort of would think more outside the box in this case to target such systems. And I wonder, in particular for Indonesia, in that case, because we have challenges in the size of Indonesia, the number of islands that on the fringe of the Indonesian areas, and this is very difficult to I understand it's very difficult to monitor, to detect, and to guard them, right? So that's what I think.
Okay, thank you. Yeah, I agree with you. Yeah, maybe we have to work more harder. I mean, for the military, it's very vital to trying to better monitor who is the attacker, where it comes from, and let alone the motives. So we wouldn't be able to to go that far. What is the motive? But for the military, it's very important to identify whether the attack is from the state adversary or non-state adversary. But it's possible for both are possible. Terrorists can do the same, as well as the nation state to attack our information system in the military. To especially when we deal with information with very sensitive technology like nuclear, nuclear weapon, missiles. It can mislead the use of the military equipments. Instead of attacking the targets, it can go back, return to your own base to attack yourself by misleading the information by using AI, by creating chaos in the information system. So I think that for the military, I think it's very important to identify whether the threats coming from state adversary and non-state adversary. Yeah. Thank you for your questions.
Right. Thank you for the answer.
Thank you.
Thank you, Pak Dila and Pak Jonni. Next, we have a question in the chat box, the question and answer from Penny Hanggarini, the doctoral student in the Unhan. Yeah, the question is that, do you think we can develop the AI without the support of the knowledge and technology from the developed countries? Who will then benefit from this? And then what are potential form of cooperation that can be developed between Indonesia and the other country in bringing the best of AI can offer to support the national interests? Thank you. Can you answer, Pak Jonni?
Yes, thank you very much for that question. I think the knowledge is very universal, and there is no way to limit within certain countries. Of course, developed countries benefit more because they start earlier than we did, and they initiated. I mean, they have all what they need for developing the knowledge, the equipment, the facilities, monies, and everything. But I don't think they can limit the knowledge within their own boundary. We can take benefits of the current development of AI by using many facilities. I mean, with the all open information, internet, and everything. Of course, we need. You are asking whether we can develop our own AI without the assistance from the developed countries. Well, depends. I mean, I think so many experts now in Indonesia, so many research in AI, including in the military. But the cooperation is still essential. I mean, especially when we talk about cyber threat, there is no any other country can keep the threat within its boundary, right? The cyber threat is cross nations. The cooperation within between nations, whether it's multilateral or bilateral, is very important. For example, in our ASEAN cooperation, ADMM, ASEAN Defense and Security Cooperation, we have expert working groups for this cooperation. The progress for cooperation is probably not as expected because of so many issues involved, including trust and the gap between the countries, and also I think the code of conduct procedure, or is I mean the protocols how to manage cyber space with among ASEAN countries are still in discussion. In the last meeting in Nadi, I was involved in network of ASEAN defense institution, the second track of diplomacy. Actually, the topic is about cyberspace, about cyber cooperation. So the challenge is still high. I mean, whether we are able, we are willing to, to create a common platform, common protocols is one of the challenges. But also I think it's quite difficult to draw the line between which one is when it's a national responsibility and which one is international responsibility to take care of it. So so many issues involved in the cooperation in terms of cyberspace. So I think the cooperation in cyber security, in AI technology, I think is very essential, and it's going to benefit um, humanity, not just a national interest. Of course, some types and characteristic of AI being used, for example, for the military is going to be connected to the national security, and of course, it's not easy for developed nation to to give up the technology or to share with other countries. But I think the technology in AI is not solely belong to the advanced nations. We can. It's just how willing the government to pay attention to this this needs for developing our capability. How much, for example, the private government private partnerships in Indonesia, because if you see mostly AI in sensitive technology owned and operated by private companies, more than what the government can do. So I think this type of cooperation, not only international, but also in national level, the government-private cooperation is something need to be strengthened as well. That's all I can answer your question. Thank you for that question.
Okay, thank you, Pak Jonni. I think the second question in the question and answer chat box, it is very similar to the previous question, but I think perhaps I want to ask my own question. So learning cyber security, cyber defense is just like chicken and egg, So we don't need to wait until we are attacked, then we start to learn how to defend such attack, right? So what do you think, Pak Jonni? So yeah, probably we better have our young generation hacker, right, to create any attack at all, and then we try to study, learn, analyze one by one how to attack if such attack happen to us. Okay, that's my question.
Yeah, that is very interesting question too, Pak. Thank you. Yes, we don't have to wait until we are attacked. We can develop our cyber security before the threats coming. So that's why I think in many universities, in our university, Defense University, we have postgraduate and undergraduate talking about AI technology and cyber. Just I think just yesterday there were competition among students in Akpol. Our students are involved and get the first winner.
Oh,
the hacker.
Okay.
The hacker team. So I think our young generation are very creative. They have a better creativity than our generation. What we need is just to facilitate and provide environment for them to study and to do research and to develop their own capability. So, but I think development in AI is something essential. It's not only for the military, but also for the benefits for the whole humanity, to make our life is much easier.
Yes.
Even though it's also controversial. Some people say that AI will replace so many jobs in our life. I remember one book written by Noah Harari, 21 Lessons in 21st Century. He said, When you grown up, you don't have job. That is a warning for the new generation. But it's not. I mean, some other perspective also in another book. You say the fourth age, by Baron Rees, Smart Robot Conscious Computers and Future Humanity, that I also enjoy reading it. There are some scenarios where some jobs will disappear, but also the AI will create other jobs too. So I mean, we shouldn't be scared of it. I mean, the future development of AI will need to be supported.
Yes.
So I think we are good. I mean, we are good to go with AI. We have facility, and but we do need to provide more environment, a better environment for them to study.
Okay, thank you very much, Pak Jonni, for your very interesting and insightful presentation. We learned so much today, and then I think we have reached the end of the session, and I will thank Pak Jonni especially. Please give a round of applause for his presentation, and then also I would like to thank, yes, the attention and participation for all participants. I think we learned so much today about the very broad application of AI in the defense domain. Okay, I think that's it. Thank you very much. We will back to Hafiz as an MC. Thank you.
Thank you, Pak.
Thank
you,
you.
everybody.
Thank you, Dr. Isal and Major General Jonni Mahroza for insightful discussion on this afternoon. So please, once again, give a round of applause to our speakers and our moderator. The next agenda is second plenary sessions that will be moderated by Professor in Faculty of Computer Science, Universitas Indonesia. Also the General Chairs of ICACSIS 2022, Professor Wisnu Jatmiko. To Professor Wisnu, the time is yours.
Okay, thank you. Mr. Hafiz. Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Welcome to the second plenary speaker at ICACSIS and IWBIS 2022. Before we begin, I would like to introduce you to the speaker. Yes, actually the speaker is Prof. Maria Valdes Hernandez from the University of Edinburgh, UK, because maybe she still have COVID. So maybe her colleague, Dr. Muhammad Febrian Rahmadi, will deliver the plenary speech. So I will introduce Dr. Muhammad Febrian Rahmadi. Is a faculty member of the Faculty of Computer Science, Universitas Indonesia. He also affiliated as a postdoctoral research scientist at Brain Image Analysis, BIA Unit Riken Center of Brain Science, Wahyu, Japan. And also in the Riken, he working together with Dr. Hernandez, the leader of the BIA unit, to develop a machine learning or deep learning technique for processing and analyzing marmoset brain image data. His main area of interest is a medical image analysis and computation using data-driven method, such as a deep learning algorithm. He did PhD and MSc studies at the School of Information, University of Edinburgh, supervised by Prof. Taku Komura and co-supervised by Prof. Maria Valdes Hernandez. At the time, he was affiliated with the Computer Graphic as Visualization CGVU research group in the Institute of Perception, Action and Behavior, School of Informatics, and the Center of Clinical Brain Science, CCBS. Without further ado, I will to welcome our presenter to start the presentation. Dr. Muhammad Fabian Rahmadi, the time is yours.
All right, thank you very much, Professor Wisnu, for your kind introduction. First of all, I would like to try to share my screen. All right, so as it has been mentioned by Professor Wisnu Jatmiko that it was supposed to be my PhD co-supervisor, Professor Maria, to give the presentation. However, because she's still recovering from COVID, so she cannot attend the presentation. So I would like to extend her apologies that she cannot really attend and do the presentation by herself. So I will do presentation on her behalf, and the title of the presentation is Modeling the Progression and Evolution of White Matter Hyper Intensities Using Deep Learning, which was basically my PhD topic, and currently still doing it together with Maria as a joint research program with CCBS in Edinburgh and also Buyya in the region Japan. So this, first of all, maybe I would like to firstly introduce Maria herself because Professor Wisnu has already briefly introduced me. So I would like to introduce Maria on her behalf. So she got her bachelor and then master in Cuba from Central University of Las Vegas in 1991 and 1994 respectively, and then she went to Japan and then got her PhD in electronics and informatics from Brunei University, and I believe that her topic was geosensing. And after that, after several years, she went to UK and then obtained her postgraduate certificate in 2012 in university teaching from the University of Edinburgh. And then currently she is working as a Rowe Fogo lecturer in medical image analysis, and then work in Center for Clinical Brain Sciences, or CCBS, which is part of Edinburgh Neuroscience and Edinburgh Imaging. And also she is part of small vessel disease research. So I would like to also introduce a Center for Clinical Brain Sciences, or CCBS. CCBS is part of the Deanery of Clinical Sciences in Edinburgh Medical School in the College of Medicine and Veterinary Medicine. And CCBS undertakes fundamental and clinical research into major neurological disorders, also playing a key role in translating research findings into benefits for patients. There are several research centers, and she is now part of Neuroimaging Sciences, where the director is Professor Joanna Wadrow, and she is quite really famous for her works in small vessel disease and stroke. And also CCBS is part of Edinburgh Neuroscience, the vibrant and integrated and interdisciplinary research structure that facilitates interaction between researchers across groups, centers, and schools and colleges. So this is quite interesting because Maria got her PhD in electrical and engineering schools, but then she entered the CCBS, which is practically part of medical schools, and then she is now the neuroimaging research scientist there. Now, I would like to also introduce Edinburgh a little bit. If you maybe follow the funeral of the late Queen Elizabeth II, so technically this is the capital of Scotland, and technically at the time I was working at the Informatics Forum, which is the the headquarters of the School of Informatics, especially for the graduate schools. And then at the same time, I was also affiliated with the medical school, especially the CCBS. So I also had an office at the Chancellor's building, which is located within the Edinburgh Buyya quarter, which is also the place of the Royal Infirmary of Edinburgh, which is the biggest hospital in Scotland. It's quite far away, but it practically 30 minutes by bus. And then, while on the other hand, Informatics Forum is really at the central area, which is really close to the Edinburgh station and also St. Giles Cathedral and also the Palace of the Holyrood House. So it's quite very, it's really interesting place to live at the time. So talking about our research, especially at the time when I was a PhD student, we were focusing on white matter hyperintensities, or we usually call it as WMH. So WMH are neuroradiological features seen in T2-flare MRI, and WMH are characteristic of small vessel disease, or SVD, and commonly associated with stroke, dementia progression, and Alzheimer's disease, or AD. So some clinical studies have indicated that the volume of WMH on a patient may decrease, regress, stay the same, or increase over time, especially the volume. So if you look at this image, this is an example of T2-flare MRI, and we can see there are white regions or white clusters, and these are what we call white matter hyperintensities. On the other hand, on this figure in the center, it's practically showing the volume of white matter hyperintensities in respect to the age of the patients. And basically at the time, at this study, the author divided the progression of WMH volume into 3 different categories: the mild, moderate, and then severe progression. And then the y-axis here is the WMH volume, and then we can see that how WMH progress over time. And at the same time, we can see that some of patients having the WMH volumes regressing a little bit, but at the end of the day, it will progress in the futures. And then also another study showed that we can technically categorize WMH into different, not regions, but what is it? Whether the WMH will be stable in the next year, or shrinking, or stable. So this is practically, this is how we can, you know, represent the evolution of WMH in the especially. So if, for example, if we have a baseline MRI and then we took another MRI scan for the same patient in the next feature, for example, in 1 year, then we technically can do a registration and then see which WMH will stay the same or progressing, which is basically just growing or shrinking. So technically that's the categorization of WMH. So this is at the time, yeah, we really focus on wanting to create or propose a model to be, so that the model can predict the progression or evolution of white matter hyperintensities, especially using deep neural networks or deep learning. So the scientific significance and the motivation is the precision medicine. So precision medicine means that we can design a patient-specific therapeutic intervention for so rather than we have a statistic-based model to give a therapeutic intervention, we would like to have a very specific patient-specific therapeutic. And unfortunately, even now, there is no way for the physician to be able to predict whether a patient will have a growing WMH or not. So we would like to propose a model so that we can predict the evolution of WMH in the future. So to the best of our knowledge, our studies in 2019 and 2020 are the first studies that implicitly modeled the evolution of WMH using deep learning and deep neural networks. So it was really interesting at the time. And yeah, that was the main objective of my PhD thesis titled Development of Machine Learning Schemes for Segmentation, Categorization, and Evolution Prediction of White matter intensities in structural brain MRI. And if you are interested, feel free to read the PhD thesis, and then because it is an open access and can be accessed via the Google Scholars. So when we did this project, we technically had three different problems. The first problem is that how do we represent the progression of evolution of WMH from brain MRI? The second problem is what kind of deep neural networks that can be used for predicting WMH progression or evolution. And then the third problem is, do we need incorporate any other clinical data modalities, for example, other than brain MRI for these purposes? Because as we know, whenever a patient comes to hospitals, not only MRI scans get scanned, but also other clinical data like maybe blood pressure or maybe cholesterol or maybe from blood tests. So we were still not sure whether this clinical data will be useful in predicting the evolution of what matter intensity. So these three problems will be the foundation, and then the topics that we will try to cover in this topic. Hopefully we can discuss all of them. And the first one is the first problem, which the representation of WMH evolution. So at that time, we proposed what we call disease evolution map, or DM, which we used to represent or characterize the evolution of WMH over 2 time points. So at the time, we only had a data sets of around 250 patients scanned 2 times, baseline, and then follow-up. The follow-up is 1 year after the baseline. So we would like to know whether from these 2 time points, whether we can predict the future. I mean, for other patients, for example. So technically speaking, we can perform subtraction between 2 manual labels of WMH from 2 time points. This is an example. We have WMH label from the follow-up, and then we subtract it with the baseline. So then we will get the disease evolution map, where the blue one is the stable WMH, the green one is growing WMH, and then the red one is shrinking WMH. So this is another way. This is one way for us to represent the evolution of WMH. However, we found that there are many ways to represent WMH. Of course, we can use the WMH label, but we also can use the probability maps obtained from automatic WMH segmentation methods. For example, if we train a CNN model to perform WMH segmentation, then technically the output from the CNN, which is the probability maps, can be used and then also subtracted again between the 2 time points, and then we will get another disease evolution map, which we call a probability map, DM, where the one is where the WMH will probably grow, and then the -1 where the WMH will probably shrinking, for example. So this is basically showing how the change of probability values for all pixels in 1 year. And another one is actually using irregularity map or IM, which is obtained from our proposed methods called LOTS IM. This is very similar to the probability maps, but the irregularity maps is have a better granularity over or more detailed categorization of WMH, and we will see in the next slides. The type of DM itself will be very similar to the probability map, where the positive value will means that the irregularity value for each voxel is increasing, and then the negative will be decreasing. So limited one-time sampling, or LOTS-IM, is a method that also we proposed around 2018. And then this is practically a flow chart on how we can produce an irregularity map from T2 flare, which is practically a texture, a texture analysis. So we practically sample target patches from the whole image, and then we divided the T2 flare MRI into source patches, basically grids, and then we compare each grid with all the target patches, and then using this distance D, then we will see how different this one particular grid to the target patches. And then because the idea is, if we sample really good, then most of the target patches will be non-white matter intensities levels or target patches. So technically, the distance will be very similar. And then when we have a grid where it contains WMH, then the texture will be very different compared to target patches. And then in here, we calculate or use different size of grids from 1 by 1, 2 by 2, 4 by 4, 8 by 8, and we can see how the results of the distance calculations, where one is is indicating how irregular that particular grid, and then after that we combine these four and then do some kind of upsampling, smoothing, blending, and then penalty, and then we will get the final irregularity maps right here. Now this is the comparison between irregularity map and then probability map. So this is the original. This should be the original input of T2 flare MRI, and then this is the segmentation or manual segmentation of WMH. So, and then this is the output from the LOTS-IM, and then this is the output from a 2D patch CNN called Deep Medic model. And then we can see that the granularity of the CNN usually located on the border of a WMH, right? And then it always have 0 probability value for the non-WMH area, which makes sense, right? But using LOTS-IM, we can see that it categorizes WMH better than probability maps, because the higher intensities from WMH will have a higher irregular values, right? So we can see that a fine grind gradual from high irregularity into the low irregular of values. And then at the same time, we can still use it for the WMH segmentation, which compared to the probability map, it's also really good. And then, so irregularity map have informations from both WMH and the non-WMH. Here we can see that there are some texture for the non-WMH, but for the probability map, all this information are gone. And practically, we at the time argue that irregularity map has more intense information density compared to probability map, and it should be very useful to be used for predicting the progression of WMH. And at the time, we also found that the irregularity map has better characterization of WMH texture, where if we look at the T2 flare MRI, we cannot see the difference between the cluster of WMH between the, for example, here, the left and right. But using the IM, you can see that, okay, the left WMH have higher intensities than the right one. And also, we showed that using IM, we can do a simple simulation of the WMH evolution because we have irregular values for all the tissues of the brain. So technically, we can do or perform simple arithmetics like addition and then also subtraction to, create what we call pseudo-healthy, where, and this is an example pseudo-healthy that was produced from this T2 pair original without the WMH. We can see that it's very good. And because we can use irregularity map value to produce pseudo-healthy, we also can produce or generate, for example, the intermediate results. For example, here we can see how WMH become smaller, and then disappear and produce pseudo-healthy by doing a subtraction for iteratively. And at the same time, we also can perform simulation of the progression of WMH by adding the value of the irregularity maps iteratively, and then we can see that the WMH becomes, especially their intensities are become higher and higher and higher. However, in this simulation, the regression and the progression usually at around the same rate for all the voxels, and this is practically not right in the WMH, because from the WMH there are some regions, or there are some clusters that will appear, and then there are some clusters of WMH located on different sides of the brain will also maybe grow or just stable. So this is not really good. This is just like an example how we can use an irregularity map for the simulation of WMH. So after we figure out that, okay, we can use 3 different representation of WMH for predicting the evolution of WMH, then yeah, practically we can use those 3, right? So we have binary label, probability map, and irregularity map. For the from the binary map, it's just like a simple segmentation, right? Because it's just the segmentation of 4 labels: the background, shrinking, growing, and then stable WMH, and then we can use a supervised. And this is basically we can use any deep learning model, and then this is practically a supervised approach. However, of course, we need an expert 2 labels for all the patients, and also at different time points, which is quite expensive. For the other parts are, for the other modalities are a little bit different. For example, for the probability map, it is kind of indirectly supervised because we need to train a segmentation model to get the probability maps. But then we can use what we call DEP GAN, which is a model that we proposed at the time to predict the progression of white matter hyperintensity evolution using probability maps and then irregularity maps. And compared to irregularity maps, if we use irregularity maps, it's practically unsupervised methods because the loss IM itself is an unsupervised method. And then the DEP GAN itself, it's technically, well, not really unsupervised, but technically it's just like, kind of reconstruction from one time point data to another time point data. So without any labeling from the human directly, we can predict the progression of white matter intensities. So let's talk about the EPGAN first, because for the segmentation, it's just like, yeah, we can use any other segmentation model that we have had so far in the from the previous studies, but this is practically the novel model that we proposed at the time around 2019, but it was then published in Medical Image Analysis Journal in 2020, which is still arguably the highest impact journal for medical image analysis. So practically we have a generator. So this model is practically a conditional GAN, and the input is a real irregularity maps of the baseline. So that's the baseline irregularity map. We input it to a generator called MX, and then the output would be the fake or predicted disease evolution map, right? Using, so we can call it as a y-axis, and then we use a discriminator, or we can just call it discriminator or critics. It really depends on the optimization, but technically we use some kind of adversarial trainings so that the fake disease evolution map mimic the real DM, right? At the same time, because the way we create DM using using subtraction, then technically we can do addition, so that we can simulate what would the follow-up irregularity map looks like. So by adding the first real irregularity map with the either real DM or fake DM, we can technically generate a follow-up irregularity map. And then we will use another critic or discriminator, so that to make sure that the generated follow-up irregularity map is also following the texture or the information of the real irregularity map in the follow-up. So that's the model that we proposed at the time. And then this model can be used for either or for both irregularity map and probability maps, DM. And this is the architecture of the EPGAN. I don't really want to explain it in this session. I mean, if you are interested, feel free to read this paper, and then this is open access, so feel free. But there are technically several loss functions so that we can produce the best results. Now for the supervised, it's much more, as I say, very straightforward. In this case, at the time we used USNet because it was used by my college for double image segmentation, and then it was also used to produce the irregularity maps. Sorry, the probability map for this study as well. The different this slide only I want to show that technically here it's still the same generator that we use in the EPGAN without any discriminators. So it's still the same architectures, but the difference would be change this activation function from tan H into the softmax, so that we have segmentation networks instead of generator. Now, for the third problem, if we still remember, we want to know whether adding any clinical information would be beneficial for us when we predict the evolution of white matter intensities. And then technically, that's the reason why we propose this yellow, architectures, which practically what we call an auxiliary input. And this auxiliary input can be used to incorporate any non-image modalities that might be needed. And at the time, based on the clinical studies, we use volume of WMH at the baseline, and also this is the first setting, and then the second setting is the volume of WMH and the stroke lesions at the baseline. And then the third option or settings that we tried is using just Gaussian noise. So basically, by adding Gaussian noise into these architectures, basically there will be some kind of uncertainties based on this Gaussian noise. Right, so this is the results. There are so many results, tables, and then figures in this paper, but technically in here I would like to just show what is it? Yeah, just want to show the results a little bit. So the red box here is the dice coefficient, which practically is to show how good the segmentations are for the change. So this is for the entire WMH, this is for the changing WMH, this is for the stable WMH, shrinking, growing, and then there is average for the shrinking, growing, and then the stable WMH. And then from this spatial analysis, we can see that actually the best one is still the supervised approach using the DEP-URASnet, especially for the average. It's still the base. It's still the best approach. And then if we use the irregularity map, it is practically not good at all. However, if we use a probability map, we can see that actually the performance is really comparable to the if we use a supervised approach. So we found out that the suboptimal, if we would like to have to predict the evolution of WMH, is just to use probability maps if we don't have labels in multiple time points, because it is very expensive to create this these labels. So we can use only just use the probability maps practically. All right, apologies for that. And then feel free to see all the results in the paper, but technically we cannot really use only we cannot do evaluation for in spatial domain, but we also have to look at in the volume as well, because usually in clinical perspective we only want to know whether the WMH is going to bigger in volume or not. So in here we can see that the volumetric bias between the predicted volume and then the real volume, and then we still can see that the supervised approach is still the best approach that we can have so far. All right, so this is the conclusion of this study. So our study in 2020, the DEP-URASnet and then DEP GAN using irregularity map and then the DEP GAN using probability map were proposed to model the WMH evolution. We also found that a supervised approach is still the best approach if you would like to do that, even though at the same time the dice coefficient is still very low. It's at the time it was around 0.1477 for growing WMH and then 0.1717 for the shrinking WMH. And we also found that the stable WMH are relatively easier to be estimated than stable and growing WMH. You might think that, oh, but the best dice coefficient is 1, right? Right. And we can see that stable is still 0.6. But several studies have shown that for WMH and, for example, for stroke lesions, usually the best dice coefficient that we could get is around 0.8, 0.7 to 0.8, because these two problems have a very high intra and then intra variability. So having dice coefficient of 0.7 and 0.8 is already very good. So in here, when we have 0.6 for stable WMH, it's actually quite good. However, if we use this supervised approach, technically, then we will have to have manual label of 2 time points and then for all of the data. So it is much more expensive compared to the other approach. And at the same time, the indirectly supervised using the EP gun and then probability map produce close performance to the supervised model. And then in general, it is still very hard for us to model the evolution, especially for the growing and then shrinking WMH. And other things, we found out that there's another problem, which is a spatial uncertainty. As we know that if we represented the evolution using DEM, especially from the binary maps, then in the segmentation problem, we will have a very high degree of uncertainties in the prediction. For example, this is the manual label of DEM, and this one is the prediction of DEM. We can see that it is quite good. There are some errors here and there, but if we, what is it? What's the best way to say it? If we divide the prediction or the segmentation, for example, this one is segmentation using all the channels, right? From the background, shrinking, growing, and stable. And then if we divide into so that we only segment or do segmentation using the background and growing WMH, we can see this is the segmentation. And if this is the segmentation, if we only use background and then shrinking, and then this one is for segmentation, if we only use background and stable WMH, then we can see that, for example, here between these two, that the growing and then shrinking WMH are basically are in very similar position or spatially. So it is sometimes the the highest probability values in this area. Sometimes it's very close to each other between the growing and the shrinking. So there are a high degree of uncertainties between these two levels. And then this is our, if we don't really cover or if we don't really try to handle this uncertainty, then it's practically very hard for us to perform the segmentation and then predict the DEM of WMH. All right, that's all from me. And this is the acknowledgement, the funding that we used during this research until 2020. Yeah, I think that's all from me. Thank you very much. And then I will give back to Professor Wisnu. Thank you.
Okay, thank you, Dr. Muhammad Febian Rahmadi, for the very nice and great presentation. All right, now we will move to the question and answer session. Maybe to the all participants, if you have any question, leave the question in the chat box, and maybe also you can directly raise hand, and then maybe you can discuss directly to the Dr. Muhammad Febian Rahmadi. Okay, maybe I just want to discuss a simple one maybe in the beginning, Mas Dr. Febian. As I see in your proposed method, the EP gun, okay, the EP gun, there is some, I don't know, usually the gun is generate some not real data, just synthesis data, isn't it? But in your proposed method, you say it's a fake disease. So I don't know. This is a standard from the medical issue, or yes? This is the first question. And the second one, usually the the most important thing, maybe, I don't know, maybe correct me if I'm wrong, about the data set in the medical research, for example. So when we create with the GAN, for example, use a synthesis data, or maybe you call the fake data, it is acceptable in the term of the medical research issue. Maybe this is just a beginning question. Please, maybe you can directly answer the question, Mas Dr. Febrian.
Right. Thank you for your questions, Professor. So technically, the fake term is practically, I would say that it is a very technical term from the computer scientists, from the computer science, or practically in the computer vision research group. And then for the medical imaging, we usually call it a synthesized or maybe generated image, but technically they are the same. In this study, what we try to do is to simulate the progression of the white matter hyperintensities, especially using the irregularity map and then probability map if we use the EP GAN. So what we try to do is to generate what would happen in the future, of course. So without any simulation or generated image or any synthesize, so it is practically almost impossible, actually. So that's especially if we use irregularity map and then probability map. So without the simulation, then there's no way for us to do it. The proposed methods might be different. For example, maybe now we can use any other methods, especially more sophisticated generation model, maybe for using diffusion model or something. But the idea is still the same. We still have to perform some kind of generation or synthesize. So that's the answer. And then for the usage in medical imaging, it really depends on the purpose of the generated image or the synthesize. So for example, if we want to, in this case, in this project, to predict what happened in the futures, then as I said, there's no way other than simulating what would happen. But at the same time, there are actually many studies using synthesized or maybe generated image to see what would happen or what would be, for example, of this patient if without brain stroke or maybe brain tumor, what would happen or what we would like. So there are many, I would say there are many studies being used in generation. But to be used in clinical setting, then that's a different question. So as we know, in computer vision, sometimes some people use a generated image for better generalization. That's also possible, but I haven't seen that many in the medical imaging because the bias from the generation is also not that easy to tackle. So it really depends on, I would say that it really depends on the usage. So yeah.
Okay, thank you, Mas Dr. Febrian. Any question from the floor? Because I think it's very interesting topic because at least we call the multidiscipline approach, at least two aspects from the medical issue and also from the computer science issue. As I see in this participant, maybe there is some student from the medical faculty, but I don't know, maybe. Okay, if maybe there is no question, maybe I will give some discussion. Not question, maybe, Mas Dr. Febrian, because I already explored maybe from your publication, for example, for the medical image analysis and another publication, because I looked maybe if I look for more detail, there is some many we call a data set because when you did your PhD, at least you belong to I don't know, to affiliation, belong to the faculty of computer science and belong to some medical research center. Right? So how you maybe give some advice for the student maybe or for the researcher when maybe you can maybe explain maybe your experience during you took the PhD and you can publish some good a journal, and I think not more than 3 or 4 journal, yes, related with the computer science and medical issue. So I don't know, maybe you can maybe give the experience maybe in the UK, for example, and I don't know, you have some experience in Indonesia maybe, but you are not still in Japan maybe, but maybe please give some experience or some guidance when maybe for the researcher who will do some multidiscipline approach. Okay, any guidance or any maybe good experience that maybe we can learn from your experience to maybe publish in some good journal related the multidiscipline approach, Mas Dr. Febrian?
Right. So the usual approach, especially if we talk about data in medical, especially from a hospital, for example, usually the data is open for publics after first it has been a clinical study has been done, and the second one is then the data is already clean. So my data sets that I used during PhD was I think captured around 10 or 12 years ago. So it's already old data sets. And this data set have been used extensively in clinical, especially from the faculty from School of Medicines. So that's the reason why the data then is open to all, for example, for all other schools, especially at the time to be processed at the time. So that's usually how it is done. And then secondly, when the data is ready to be published, usually the data is clean. So for example, at the time, I don't know the names or the age or even, I mean, I know the age, but I had to ask specifically for this clinical data. And then usually Maria, who was my co-supervisor, who did the clinical analysis, not me. So the MRI data itself was already clean in terms of no names or so. Yeah, so practically, especially in medical, usually what we want to have is that when we look at the data, we don't really know or we cannot trace back to the patients. So that's as long as that is correct. For example, we can publish the data after the skull is removed, for example, or maybe the data after the data is normalized somehow, or after it is registered to a standard space. So there are many ways for the data to be published, and then all people can use it. And then in terms of the open data itself, the UK is, I think, one of the biggest medical data right now. If we search Google, we can look. The name of the data set is a UK Biobank. So the UK Biobank is technically still the largest medical data open currently, and then open for, I think, I don't know whether it is open for the UK students or UK universities, but I think they are open for research anyway. And it's also not only imaging, but also like I don't know whether it's DNA or something, but like a gene or maybe the whole brain MRI, and a whole body MRI. So there are lots of data in the UK Biobank. So that's usually how. Maybe we have to look at the protocol of what they do in this, what they usually do for opening this data. But yeah, I mean, without any data or opening the data, especially between the faculty of medicines, then yeah, there will be no new interesting research between, especially if we want to use deep learning in this case.
Okay, thank you. Maybe one question from the Q&A box, maybe. Could you read directly, Mas Dr. Febrian?
Yeah.
Question from the Mbak Cynthia Deborah.
Yeah, so the question is, based on the results of the study, how likely is the failure of this model in predicting the evolution of WMH that will ultimately results in errors when diagnosing disease, maybe? As we know that this model is very dependent on image and actually input which is processed. Yeah, exactly. So this is, I mean, even for my PhD, we realized that this is a very early research, honestly. As previously mentioned, we believe that this is the first ever research in modeling the progression of brain lesions in terms of, for example, the white matter intensities. So no clinical studies have been done. So usually, especially in the UK, if one automatic methods it's going to be used in clinical setting, usually after a technical publication, there will be another research which is for a clinical research. So technically, to compare whether the methods can generalize in the clinical settings. So in this case, we don't really know. I mean, the only thing that we know is, of course, on the data sets that we have. And then, yeah, I mean, as we currently say, is that it is still difficult to do the exact, prediction of WMH evolutions, especially because there are high uncertainties between the shrinking and then the growing WMH. So yeah, I think without any advancement in the machine learning topics, deep learning topics, I mean computer science topics, and then also without more data, and then more patients, and also more time points to evaluate these kind of models, then yeah, there's no way for us to really say, okay, this model is really good. No, there is no way. So, but hopefully, of course, because now everyone is just like procuring data or getting data from the patients from different time points, and then that's exactly what the CCB is currently doing, getting more data from new patients from more time points, so that we can have like a better understanding from the clinical perspective, and also can be used in create a new model and then a better model. Then hopefully some days it will be used in the clinical settings. But yeah, that's the only thing that I can say.
Okay, thank you, Mas Dr. Febrian. Because the time maybe before we close the session, please give the great applause to the speaker, Dr. Febrian Rahmadi. So finally, now we have reached the end of this presentation, and I would like to say thanks you to all the presenter for the, especially for the Dr. Febrian Rahmadi, and to the audience for their active participation. And thank you again for your attention. And I will return back to the Mas Hafiz, the moderator. Thank you.
Thank you, Prof. Wisnu and Dr. Febrian, for the discussion on this afternoon session. Once again, please give a round of applause to our speakers and moderator today. Ladies and gentlemen, the next we will have 15 minutes breaks, and then we will have parallel sessions with several topics that starting at 4:15 p.m. on Jakarta time. So to all presenters, please join your assigned room for your presentations, and to all participants, please join any parallel sessions that you are interested in. And the link to the parallel session you can be found on the advanced program of both ICACSIS and IWBIS 2022. And that's all for today. See you tomorrow on the second day of ICACSIS and IWBIS 2022. And goodbye and see you. Thank you.
In this digital age, information technology has become an integral part of human life. People use technology to facilitate all kinds of activities in various aspects of life, such as the economy, education, transportation, social, and health. Established under the name of Computer Science Center of Universitas Indonesia in 1972, the Faculty of Computer Science Universitas Indonesia is based across two sites, Depok, West Java, as well as Salemba, Jakarta, both located in the Greater Jakarta area. The faculty is the unique place for people who are curious and passionate about innovating and working in technology, especially in the fields of computer science and information systems. The fields of computer science and information systems are both related to technology, but there is a fundamental difference between the two. Computer science is about developing technical solutions for problems such as operating systems, algorithms, multimedia, information security, artificial intelligence, data science, and others. While the information system is about applying and integrating these technical solutions to address organizational or business problems. A computer science academic program is designed to include extensive knowledge in computer science, ranging from basic knowledge such as programming and how the computer works, up to advanced knowledge such as software engineering, artificial intelligence, and infrastructure and security. On the other hand, an information system academic program does not only include basic knowledge, such as those studied under the Computer Science Study Program, but also the foundation in the fields of business administration and management, which help prepare students to develop, utilize, and manage information systems or information technology. The faculty has two academic programs at the undergraduate level, namely a Bachelor of Computer Science and Bachelor of Information Systems. For those who are interested in computer science, the faculty also provides an international undergraduate program in computer science with an opportunity to earn a double degrees in collaboration with partnering universities overseas. At the master level, the faculty offers a Master of Computer Science and a Master of Information Technology programs. For both of these master's programs, the faculty also provides an opportunity for students to complete them through a double degree with an international partner university. At the doctoral level, the faculty offers a Doctorate in Computer Science program, which has produced many leading scientists and researchers in the fields of computer science and information systems.
Faculty of Computer Science Universitas Indonesia has a vision as a center of excellence in computer science and information systems that is recognized by the international scientific community, well organized, and contributes significantly to increasing the competitiveness of Indonesia as a nation. To achieve our vision, we commit to implement three goals, namely excellent education, professional research and service, as well as the outreach programs.
As a nationally accredited institution, Faculty of Computer Science Universitas Indonesia is widely recognized as the leading academic institution in computer science and information systems. At national level, our students have been part of the Universitas Indonesia's team that has become the reigning champion in the largest ICT competition series for Indonesian students, locally known as Gemastik. The Universitas Indonesia's team has won the annual Gemastik 8 times, including 5 times in a row in 2016 to 2020. At the international level, the faculty also routinely gain notable achievements, such as at the 43rd Annual World Finals of the International Collegiate Programming Contest or ICPC, where Universitas Indonesia was ranked 21st in the world, tied with other top universities in the world. The excellence of education and research at the faculty is also recognized by various international ranking institutions. A recent ranking publication by Quacquarelli-Simons World University Ranking by Subject 2021 places Universitas Indonesia at number 251 to 300 in the world in the fields of computer science and information systems. The faculty has a team of excellent teaching staff who graduated from various top universities in the world. Many of our professors or teaching staff are also leading researchers in their respective field. Equipped with strong pedagogical skills and educational background, our professors or teaching staff are ready to produce a new generation of experts in the fields of computer science and information systems. Various amenities and facilities that can support the learning process and various student activities. Starting from a comfortable classroom, libraries with huge collections, spacious halls and auditoriums, computer labs, to advanced computing facilities such as a supercomputer, which is readily available at the Tokopedia UI Artificial Intelligence Center of Excellence. Our student body is a melting pot with best students coming from all parts of the Indonesian archipelago. These students take part in a rich tradition of academic activities, which include 2 flagship international scientific conferences held by the faculty every year, or other programs, such as the Teaching Assistantship or the Fellowship Program. Apart from academic activities, students are also encouraged to develop non-academic skills, which are accommodated by various student organization activities, such as the Student Executive Board and other student organizations or autonomous bodies. In addition, our students are also known for their ability to organize extraordinary events, one of which is the annual Comfest event, that is recognized as the biggest student-run event in ICT in Indonesia. This is in addition to other student communities or clubs, which provides an avenue for personal development in sports and the arts. Research and development is one of key activities at the faculty. Our staff and students are encouraged to produce works and solutions that address contemporary problems faced by both global and local communities. Our research contributions are not only in the form of basic and theoretical research, but also in application of various forms, ranging from software, information systems, to intelligence systems based on robotics and artificial intelligence. More than 6,000 alumni with a network spread across 7 continents. The majority of our alumni started working while still in university. While some of our graduates are employed in various companies and institutions, such as big tech companies in Silicon Valley, startups, consulting companies, research and education institutions, others have become entrepreneurs starting their own companies. Some of the companies founded by our graduates have been successfully acquired, listed on the stock exchange, and their founders have also been rewarded many prestigious international awards.
Wasikom UI menjadi bagian tak terlupakan dalam hidup saya. Ia seperti rumah kedua bagi saya. Tempat di mana saya terbuka matanya untuk menjadi orang yang lebih baik dari hari ke hari.
Saya percaya di zaman-zaman kuliah itu sebetulnya pembentukan karakter, pembentukan mentalitas gitu. Dan UI itu is a very very good place for me to have a good character.
Fasilkom UI telah memberikan saya banyak sekali ruang untuk mengembangkan diri. Mulai dari pembelajarannya yang selalu mendorong untuk berpikir kritis, hingga kegiatan-kegiatan non-akademis seperti kompes, panitiaan yang diadakan tiap tahun, dan juga organisasi-organisasi seperti BEM, Ristek, yang tak hanya meningkatkan soft skill saya, namun juga membantu saya mengeksplorasi passion saya dalam bidang IT.
By implementing the three duties of higher education or Tridharma, namely education and teaching, research, and community service, the Faculty of Computer Science Universitas Indonesia is at the forefront of producing the best graduate for Indonesia and the world. In this digital age, information technology has become an integral part of human life. People use technology to facilitate all kinds of activities in various aspects of life, such as the economy, education, transportation, social, and health. Established under the name of Computer Science Center of Universitas Indonesia in 1972, the Faculty of Computer Science Universitas Indonesia is based across two sites, Depok, West Java, as well as Salemba, Jakarta, both located in the Greater Jakarta area. The faculty is the unique place for people who are curious and passionate about innovating and working in technology, especially in the fields of computer science and information systems. The fields of computer science and information systems are both related to technology, but there is a fundamental difference between the two. Computer science is about developing technical solutions for problems such as operating systems, algorithms, multimedia, information security, artificial intelligence, data science, and others. While the information system is about applying and integrating these technical solutions to address organizational or business problems. A computer science academic program is designed to include extensive knowledge in computer science, ranging from basic knowledge such as programming and how the computer works, up to advanced knowledge such as software engineering, artificial intelligence, and infrastructure and security. On the other hand, an information system academic program does not only include basic knowledge, such those studied under the Computer Science Study Program, but also the foundation in the fields of business administration and management, which help prepare students to develop, utilize, and manage information systems or information technology. The faculty has two academic programs at the undergraduate level, namely a Bachelor of Computer Science and Bachelor of Information Systems. For those who are interested in computer science, the faculty also provides an international undergraduate program in computer science with an opportunity to earn double degrees in collaboration with partnering universities overseas. At the master level, the faculty offers a Master of Computer Science and a Master of Information Technology programs. For both of these master's programs, the faculty also provides an opportunity for students to complete them through a double degree with an international partner university. At the doctoral level, the faculty offers a Doctorate in Computer Science program, which has produced many leading scientists and researchers in the fields of computer science and information systems.
Faculty of Computer Science Universitas Indonesia has a vision as a center of excellence in computer science and information systems that is recognized by the international scientific community, well organized, and contributes significantly to increasing the competitiveness of Indonesia as a nation. To achieve our vision, we commit to implement three goals. namely excellent education, professional research and service, as well as the outreach programs.
As a nationally accredited institution, Faculty of Computer Science Universitas Indonesia is widely recognized as the leading academic institution in computer science and information systems. At national level, our students have been part of the Universitas Indonesia's team that has become the reigning champion in the largest ICT competition series for Indonesian students, locally known as Gemastik. The Universitas Indonesia's team has won the annual Gemastik 8 times, including 5 times in a row in 2016 to 2020. At the international level, the faculty also routinely gain notable achievements, such as at the 43rd Annual World Finals of the International Collegiate Programming Contest or ICPC, where Universitas Indonesia was ranked 21st in the world, tied with other top universities in the world. The excellence of education and research at the faculty is also recognized by various international ranking institutions. A recent ranking publication by Quacquarelli-Simons World University Ranking by Subject 2021 places Universitas Indonesia at number 251 to 300 in the world in the fields of computer science and information systems. The faculty has a team of excellent teaching staff who graduated from various top universities in the world. Many of our professors or teaching staff are also leading researchers in their respective field. Equipped with strong pedagogical skills and educational background, our professors or teaching staff are ready to produce a new generation of experts in the fields of computer science and information systems. The faculty provides various amenities and facilities that can support the learning process and various student activities. Starting from a comfortable classroom, libraries with huge collections, spacious halls and auditoriums, computer labs, to advanced computing facilities such as a supercomputer, which is readily available at the Tokopedia UI Artificial Intelligence Center of Excellence. Our student body is a melting pot with best students coming from all parts of the Indonesian archipelago. These students take part in a rich tradition of academic activities, which include 2 flagship international scientific conferences held by the faculty every year, or other programs, such as the Teaching Assistantship or the Fellowship Program. Apart from academic activities, students are also encouraged to develop non-academic skills, which are accommodated by various student organization activities, such as the Student Executive Board and other student organizations or autonomous bodies. In addition, our students are also known for their ability to organize extraordinary events, one of which is the annual ComFest event that is recognized as the biggest student-run event in ICT in Indonesia. This is in addition to other student communities or clubs, which provides an avenue for personal development in sports and the arts. Research and development is one of key activities at the faculty. Our staff and students are encouraged to produce works and solutions that address contemporary problems faced by both global and local communities. Our research contributions are not only in the form of basic and theoretical research, but also in application of various forms, ranging from software, information systems, to intelligence systems based on robotics and artificial intelligence. More than 6,000 alumni with a network spread across 7 continents. The majority of our alumni started working while still in university. While some of our graduates are employed in various companies and institutions, such as big tech companies in Silicon Valley, startups, consulting companies, research and education institutions, others have become entrepreneurs starting their own companies. Some of the companies founded by our graduates have been successfully acquired, listed on the stock exchange, and their founders have also been rewarded many prestigious international awards.
Fasilkom UI menjadi bagian tak terlupakan dalam hidup saya. Ia seperti rumah kedua bagi saya, tempat di mana saya terbuka matanya untuk menjadi orang yang lebih baik dari hari ke hari.
Saya percaya di zaman-zaman kuliah itu sebetulnya pembentukan karakter, pembentukan mentalitas gitu. Dan UI itu is a very good place for me to have a good character.
Fasilkom UI telah memberikan saya banyak sekali ruang untuk mengembangkan diri, mulai dari pembelajarannya yang selalu mendorong untuk berpikir kritis, hingga kegiatan-kegiatan non-akademis seperti kompes, panitiaan yang diadakan tiap tahun, dan juga organisasi-organisasi seperti BEM, Ristek, yang tak hanya meningkatkan soft skill saya, namun juga membantu saya mengeksplorasi passion saya dalam bidang IT.
By implementing the three duties of higher education or Tridharma, namely education and teaching, research, and community service, the Faculty of Computer Science Universitas Indonesia is at the forefront of producing the best graduate for Indonesia and the world. In this digital age, information technology has become an integral part of human life. People use technology to facilitate all kinds of activities in various aspects of life, such as the economy, education, transportation, social, and health. Established under the name of Computer Science Center of Universitas Indonesia in 1972, the Faculty of Computer Science Universitas Indonesia is based across two sites, Depok, West Java, as well as Salemba, Jakarta, both located in the Greater Jakarta area. The faculty is the unique place for people who are curious and passionate about innovating and working in technology, especially in the fields of computer science and information systems. The fields of computer science and information systems are both related to technology, but there is a fundamental difference.